Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue our lesson about part number 16 that we will learn about basic math. Okay, before go to part 16, let me review the part 15. Yes. In the part 15, we already learned about the bit subvert operation, and then we already tested the Proficy Machine Edition with the HMI also. Okay, so today let's go to part 16 that we will learn about basic math. In this section, I will share about multiply integer and real, and divide integer and real also. Then we will connect to the HMI also. Okay, so here is the block ladder diagram of multiply integer. So here is the input number 1, and here is the input number 2, and here is the output. It means that the result. Yes, and divide integer also. Here is the input number 1, and here is the input number 2, and here is the result. Okay, so let's go to our software Proficy Machine Edition to create the new program and test with the function to let's see the function also. Okay, so let's go. So here is the previous project that we already learned in the previous video. So today I will create one more block for math, right? The one is the mul and divide block, and I will create a new folder for mul and div block. Okay, so drag and drop here, and then don't forget call it to the main program. Yes, so I will call it, and then double click. So actually we can use the tool chest. Yes, so ladder instruction, and then go to the mathematics. Yes, go to math, and we can use this block, drag and drop. Yes, and we also comment. Oh, sorry, it have problem a little bit. Let me open again. And let create a new folder again. Yes, mul div, and right click, choose the ladder, and then we will choose the math, or we can write mul divide, like this, and call to main again, right? So double click again, and then save first, otherwise it will lose again. Okay, So I can drag and drop again, go to here and then go to the math and choose the mul integer. Yes, and I will write command. We are learning about math multiply and divide. Okay, so we can comment mul instruction, mul integer instruction. Okay, so here is the in number 1. So mul it means that in number 1 multiplied by in number 2 equal the result. Okay, or we can mul number input number 2 mul input number 1, it will get the result also. Okay, so example mul in 1 mul example. This is a into mul. Yes, into mul, and this is the result, right? So mul q, right? So the data type is the integer. Yes, you see the data type will be integer because we use the integer block for multiply and divide, right? Okay, so that's all for multiply, and we will create one more for divide. Yes, so we can copy this command, and this is a divide, right? And we can write like this also, divide integer and connect. Yes, then I will choose in 1 divide, and this is a into divide, and this is a divide result, right? So divide underscore q, right? And then let's check our program. Yes, error 0, and then save and then download. Yes, okay. So some point maybe have problem with the existing point. I will delete first. Yes, and normally the multiply, right? So multiply we can test. So if I write 20 multiplied by 0, it will equal 0. Okay, if multiply 1, it will equal 20, right? Example, multiply by 100, it will show the result 2000. Yes, and this one should be the into not equals 0, right? So if everything example 200 divide by integer, divide by 0, it will show yes error, yes, because the in number 2 of divide block should be not equal 0, right? Example equal 2, the result will equal 100, right? So how to do to not allow the into equal 0, right? So we can use like this. If into equal 0, right? So equal or lesser than 0, right? So lesser than equal 0 integer, right? If in number 2, right, equal 0 or less than 0, then I will move integer, right? I will move 1 to into divide 1, okay, like this. So I can copy this one to the integer, right? If divide we can move 1 to this one, yes. So let's check. And download again. So if into equal 0, you see, it will move number 1 to the into divide, right? So it will not equal 0, right? Okay. If we write 0, we cannot write because it move 1 to the this variable, right? So we can write any number but not equal 0, right? Example 80, right? Right, like this. Okay, this is a multiply integer and divide integer, right? So let's see the real. Yes, so we can copy from this one the real data type, right? So divide real, multiply real, right? Multiply real, yes, multiply real. And this one we can drag and drop, or we can write like this, mul underscore real, yes. Then this one in one mul real, right? This is into mul real, and this is the result, right? So mul real q, like this. And one more for divide, we can write like this, divide real, and this one in one divide real, and this is into divide real also, but this one should be not equal 0, right? So we can less than equal real, right? Then if this one equal or less than 0, we will move real, right? So move 1.0 to this variable, right? And this is a result. So result divide real q. Okay, so let's check our program. Yes, no error occur, and then we can download again. Yes. Okay, let's see. It will equal 1 because we cannot divide by 0. Okay, so example, I choose 2.5 multiplied by 2, yes, equal 5, right? And if multiplied by 1.5, it will equal 3.75, yes. It will not the same the integer, because integer is not like this, right? For divide example, I have 50 multiplied by 2, right? It will equal 25, right? Okay, so this one I can comment, yes, copy comment. Then this one is the divide, right? Divide real instruction, and we can assign the address for test with the HMI. Yeah, so this one I will choose person A also, person A also, right? Person A. Then this one is a person A also, right? Person A also. Yes. Person A. The last one, person A, right? Okay. So we can connect to the HMI. Okay, I will download again first. Then we will create the points for HMI. Okay. So let's go to Proficy HMI. Yes. And then create the point. Right now I no need to stop the project, so I will dynamic. And then I will choose the new divide and analog, right? So I can write to be easy to remember. So in one mul integer like this, then person A number 32, yes, and we can duplicate into, right? Person R number 33, and the result is the integer result. We can write Q person R 33, sorry, 34, right? And for the divide integer, we can choose like this. Property, sorry, duplicate involve divide integer. So involve divide integer, and then person are certified, yes. And into also person are 36, yes. And one more for result, right? So can duplicate result. We can write Q divide integer person R 37, right? And the integer, right? This one is an integer, okay? And the next we will create the real, right? For real value. So here, okay, we add one by one. So I will choose new, and then analog again, and then this one for in one real. And don't forget change this one to real, right? Data type to real, and then choose the person R 38, right? Sorry, person R 38, yes. This one more for into, so person R number 40, person R 40, and the result, right? So Q person R 42, right? This one, and one more for real divide real, right? So we can choose this one in one divide real, and it will start from person R 44, right? Person R 44, and one more for into divide, right? So into divide real, and person R 46, and the last one for the result, right? So Q person R number 48, right? Okay, so right now we already created the points. So let's go to our screen and then create a new screen. and save the screen. Example screen number 7. Yes, and I will copy some format from this one. Yes, that we already learned in the previous video. Control C, and then I will open here. Okay, and then let's go to the text string. Example divide or multiply integer. Yes, change some color. Example this color, right? And change to go to font. Yes, 20. Okay, so this is the in one, right? Input 1, input 1, right? Let me change to another color to be easy, right? Like this. And this is a integer, right? So we can browse the points, go to point, and then in one, right? We start from in one, but integer, right? In one integer. Let's check our point again. Yeah, for integer multiply integer, right? Integer, it will start from this one. Yes, in one mul integer, right? So in one mul integer, and then this one integer, and set point value also. So click OK, and then copy. Yes, drag and drop by press Control and Shift. We'll change this one to input 2, right? Change this one to into, and one more for the result, right? So I can copy, and then this one is the result. So result, right? And then choose the result Q. Okay, and we can align to be center, right? Okay, so let's save our screen, and then I will adjust a little bit like this. Yes, like this, and then I will copy this one to divide. Yes, divide integer, right? So divide integer, and we can use the integer, and then for this one we no need set point because it is the result, right? This one we can browse the point by press this one and go to the in one view, right? So divide integer and set point also. and this one, and this one the result, right? So no need to set point action, and choose divide, right, integer, and one more for divide real. So we can copy one more. Okay, so this is a multiply real, so mul real input one. We can browse, or we can change this one to real, and change this one to the real, right, and set point also. And this is a precision. We can use one or two. Example, I use 2 precision, yes, and this one real also, divide real, right, and this one 2 also. This one no need to set point, right, and this is divide real result. Choose the real and then choose 2 also. Real, sorry, this one should be real. Choose real also, right, and one more for divide real. So divide real, yes, and this one divide real, and choose the real and set point value also, and precision 2, input number 2 real, choose the real and then choose precision number 2 also, and this one no need to set point action, and then this one is the divide real result, and we'll choose real and then precision 2 also. Okay, so let's adjust our screen like this. Okay, and I will adjust to be a center, and then we will save our screen and then test, right. So first we test the integer, right, multiply integer. So if I put this one 20 and this one 20 also, the result will 400, right, it correct, and this one, it input number 2, it always 1, right, if we write 0 it cannot. Okay, so if I write 2 and example 10 divided by 2, it will equal 5, right, you see 5, and this one for multiply, example 2.5 multiply by 2.735, yeah, it will like this, and this is a divide real, right. So example 1.25 multiply by 50.23, okay, the result will small because into is big, right? Example 80.01, yes, divide, it will show like this. So this is a multiply and divide instruction for integer data type and real data type that we already learned, yes, and we can create the HMI also for test. So thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my channel also to get more new notification and more new videos that I will create step by step, right? So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue our lesson about basic PLC GE. But before go to our lesson, I would like to review the previous lesson a little bit. Okay. So we already learned about part 16 about basic mathematics that we focus to multiply and divide the integer and real data type, right? And we also link to the Proficy HMI SCADA also, yes. So today we will continue to the basic mathematics also that we will focus to the scale integer, right? So here is the scaling block of integer that we have input and output. So in the input part we have 5 parameters. So first, high input, second, low input, third, high output, fourth, low output, and 5, yes, input value. So when we provide the input value, it will check and compare the low and high the input and then generate to the output value, right? So in this case we will connect to the HMI also to test. Okay, so let's go to our software to create the scaling block of integer and test with the HMI. Okay, so let's go. So open Proficy Machine Edition and then go to the existing project. Yes, this is an existing project that we already learned in the previous video. So I will create the new block, yes, the new folder, example scaling, integer, right? And then I will create the new ladder blocks, yes. So integer scale like this. and then don't forget call this block to main also, right? Okay, I will call to main block. Okay, because it is the subroutine, so we must call to the main program, otherwise it not work correctly. Okay, so double click on this block and I will zoom a little bit. Yes, so we can comment we are learning about scale integer. Okay, so to find the scale integer, let's go to our toolchest tab and then select to the instruction, all the instructions, and go to the maths, yeah, and find the scale integer, right? So many blocks that we can use. So I will choose the scale integer, right? So go to scale integer here, drag and drop to our program. Yes, and then for this one normally allow on, yes, like this. If we want to enable or some push button, we can write also, but in this case I will connect directly to the wire to the run. Okay, so here is the input high. It means that input value high, and this one is the input value low. Yes, and this one for input, sorry, for output value high that we want, and this one for output value low, and this one for input value. Yes, normally we have the formula for calculation for these blocks, but in here is the library, so we cannot open. In the next video I will focus and share how to create this block for the real scaling of real data type. Okay, so normally we can write like example like this 30,000, 32,000, like this, and this is example 0, and this is a high value, right? High scale input, sorry, high scale output. So we can write 100 like this, and this 0, and this is input, so we can write the variable for input, example scale SCL input, like this, and this is the SCL output. Okay, so if we save our program and then download to the CPU, we can view the data, right? So it is 0 when I adjust the input something, example 100, yes, it will show the scale input, right? Outload 0, from 0 to yes, 500. It means that when we provide 32,000, it means that we can get the output 100. Okay, normally the analog input card rank from 0 to 32,000. So if we would like to show 100%, we can provide the analog input to 20 milliamp or 32,000. So we will got 100% of display. Okay. So if I adjust something like the middle, example 1600, right? We will got 50% or something, okay, like this. So it is the scale. So in here we can also write variable for connect to the HMI. Example SCL HI like this, and if want SCL ILO, yes, this one SCL OLI, sorry, OHI, SCL OLO, yes, like this. So we can connect to the HMI, right? Example, this is a %R, right? We can provide the %R for integer, and this is a %R also. Yes, %R. This one %R also. Yes. Okay. So we can link to the HMI when we assign the address of variables. Okay. So we can download. Okay. And save our program. Let's go to Cimplicity Workbench. Yes. And then go to our project. And then create the points, right, from the scale. So let's go to points and then go to the new points, and we will choose the analog and device points because we connected to the PLC. So this one we can choose SCL underscore IHI, yes, and this is the integer, right? So select integer and then choose the %R 50, right? Okay, and this one we can duplicate because the data type is the same. So we can write SCL ILO, then %R 51. This one SCL underscore OHI, right? And %R 52. This one also SCL OLO, %R 53. One more for input, right? SCL input %R54, and the last one for output, right? So SCL output %R55, right? Okay, we can update our project of HMI, and then let's start. Yes, wait a moment for starting the project of Cimplicity Workbench. Okay, so right now we can create a new screen. Yes, so go to the screens, and then maybe I will create a new screen for this one, and then let me copy. Yes, from here we can Control C for copy, and then go to the our screen, and then paste, Control V. Yes, and this one we can write like high scale input, right? Like this. I will adjust to be a little bit. Control Z first. Adjust. This one is a high scale, right? And this one is the low scale. Input. And this one is the high scale output, right? So high scale output. And one more for low scale output, right? And the last one for input value, right? Input value. Actually, this is a analog input. Yes. So we can align it to be like this. Okay, and let me copy two more and adjust the screen. Yes, and this one we can write scale of integer. Yes, scale of integer. We can adjust the font to be bigger than this. Yes, or we adjust to be 36. Yes, like this, and adjust this one more. So one more is the result, right? So here is the result, so I will copy one more for result. Yes, this is the output value. Yes, output value, it is the result, right? So here we can choose the points. Example, browse the point. It will start from SCL, right? So SCL star, yes, and this is a high, yes, integer and set point action also, and this one for the brow, right? And this is a ILO, right? So this one set point action also, this one for output, yes. So here is the OHI, right? So OHI set point action also, yes. This one is brown, right? This one is OLO, right? This one set point action also, and one more for input, right? So SCL input, yes, set point action also, and for the result no need to set point, right? Because it output. So we can choose the SCL output, this one, right? So click here and then no need to set point action. Okay, so this one we can adjust like this and then align, yes, to be center. Okay, so we can save our screen, yes, later project, go to the screen and then example screen number 8, yes, and we can test our screen, yes. Okay, so right now is a high scale input, right? So I can adjust to be actually like this 32,000, yes, and this one 0, this one high value, right? High scale, example 100%, yes, and this is the input value, example 16600, yes, it will got 50%, example. So in here we can adjust something, example start from 500, yeah, and if this one 500, yes, it will show 0 because when it's with 500 it will show the output 0, right? So we can adjust the scale, example like this, yes, it will show 100% because it equal the maximum, yes. So thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon, and in the next video I will show the formula how to create this block with the real data type, yes. In this time I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue our lesson about basic PLC GE, yes, and I will show and share how to create the scale real data type, yes, it means that scale the analog, yes, example, scale the analog, but the output is the real value, okay. And here is the formula, yes. In the previous video we already learned about part 17 that we already use the block scale integer, yes, and we also connected to the HMI, yes. For scale integer we have in the library, I mean that we can add from the tool chest, yes. But for real integer, sorry, real value, we don't have it, yeah. So we need to create the scale for real value, okay. Example, input is the real value and the output is the real value also, so we need to create, right. So let's go to our software. Here is the previous lesson, yes, that we learned in the previous video about the scale integer, yes. For scale integer, actually we have, yes, from the math, right, here, and SCL integer, yes, SCL integer, yes, here. But if we would like to use the real scaling, we don't have, yeah, we don't have here, so we need to create to be the same as this also, but the data type is the real value, okay. So let's go to the program blocks and create the new layer, yes, or new folder. I can write scale real, yes, and create the new layer, yes. I will use layer block, yes, SCL real, yes. And for this block we need to create the parameter, yes, to be the same as the scale integer, yes. Actually we have 5 parameters, yes, and output 1 parameters, okay. So we need to create input for high scale in, low scale in, high scale out, low scale out, and input. Actually start from analog input, yes. Example, measure the temperature, measure the pressure, measure the current, something. We need to use the analog input, okay. So when analog input connect to here, it means it will generate the scaling, and then we will got the output value, okay. So we need to create this one. So scale integer here, but we will to scale real, and parameter, yes. So parameter is the same this one, right. Example I, yes, here ILO, OHI, OLO, and IN, yes, input. So this is all is a real, okay, for data type. So real, 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 okay. And for output we have only one, yes. but here we can comment something. Example, this one is the high scale input, right? So high scale input, and this one low scale input. This one is the high scale output. This one low scale output, and this one is the raw data or analog in. Okay, we can write like this: analog input. Okay, and for output we have only one. Yes, so let's go to output and then out. Yes, here, and this is a real also for data type, and this one is the output. Yes, okay, so I will close this one also. So right now we already assigned the parameter. Yes, parameter of the blocks for input and output. Yes, so we need to create, follow the formula. Yes, follow here. In minus low scale input multiplied by high scale output minus low scale output divided by high scale input minus low scale input. Okay, and this all to plus by low scale output. Okay, so we will got Q. Yes, we will got this one. Okay, so go to our block and then double click, and we can write, yeah, sub, right? Sub real. Yes, so input. Yes, in sub low scale, right? Sub low scale input, right? Here, low scale input. So ILO, yes, that we already assigned here. ILO, yes. And one more for subreal also, right? Subreal also. And we will here subscale output, sorry, high scale output minus low scale output. Okay, so high scale output OHI, yes, minus OHI minus OLO, right? And one more for this one, yes, high scale input minus low scale input. Okay, so sub integer, sorry, sub real, low scale input, right? So sorry, high scale input minus low scale input. So high scale IHI minus ILO. Okay, IHI minus ILO, and then we will multiply, right, this one and this one, right? So real multiply real, yes, this one with this one, right? Yes, and then we will divide all of this to this one. Okay, so divide real, this one divide by this one, right? Okay, and then all plus low scale output, right? So add real, yes, so OLO, right? Low scale output. Okay, I will adjust this one a little bit. Actually we can minimize, yes, like this. Yes, right now we already created the formula, yes, follow our formula, and we will got shoe, right, out, yes, we will got the output right here. So let's validate our block, yes, no error, and then save. And then if we would like to use this block, let's go to main program, yes, and then we can call, yes, example, I will create the new block, yeah, scale real, yes, and then call to the main program, yes, the main block, and double click, and here I will call this block to use. Okay, so let's go to call and then double click, and let's go to the scale real, right, ACL real, yes, and here we can write like ACL I HI, yes, SCADA HI, yes, and we can copy this one, SCADA underscore IHI, yeah, and I will copy this one for easy to paste, yes, here paste, and then ILO, yes, and here paste also underscore OHI, here underscore OLO, and here is the input, right, so in, and here is the out, yes, like this. So we can validate again, yes, no error occur, and then let's go to download, yes, yes, okay, so let me start the CPU, and then let's see the, so here we need to write the high scale input. Example, low scale input start from 0 to high scale input. Example 3000, 32,000, yes, 0.0, yes, because it's real value, so need to 0.0 or point something, and the output that we want, example, start from 0 to 100%, yes, example 0 to 100%. So if the input, yes, example is one connected from the analog input, right, So if input like 1 yeah 6 0 0 0.0, it will generate 50% for us because we already write the formula, yes, followed by the scaling, yes. So if we compare to the scale integer, it similar, but the scale integer we use from the tool chest, and this block we can create by ourselves. Okay. So if we would like to link this block to the HMI, we can do also. Yes. For example, it maximum info input. Sorry. Maximum, yeah, 32,000, yeah, 0.0. So it will generate 100% because we setting the high scale output is 100%. So if the input equal the high scale, it will generate 100% for us. Okay. So we will link this one to the HMI also. So I will close. Sorry, open again. I will assign some address, yes. Example person A, yes. 56. Person A 58. Person A 60. Person A 62. Person A 64. And person A 66. Okay. So save again and then download to the CPU again. And then we will link to the HMI. Okay. Yes. So let's go to Workbench. Yes. And open the existing project. Yes. And let's create the points. Yes. Create the point. Follow this one. Yes. So I will create a new point. Yes. And the analog. Yes. And use the divide point because we link from the PLC. Example, this one SCLR underscore IHI. Yes. So let's click OK and then go to real. Yes. And we will use the divide, right? So person A 56, yeah. And we can duplicate, yes. SCR ILO, yeah, for this one. And person A 58. One more. SCROHI, yes. Output high scale. And 60, person A 60. One more for OLO 62, yes. In, yeah, in that input person A 64, Actually this one we connect from the analog input. It means that percent AI1 or percent AI2 like this. It connected from the instrument. Yes, actually yes, but this is just for example, so I will assign the percent A first. I see out, okay, and percent A 66. Okay, so let update and then start our project, and then we will create the screen. Okay, so wait a moment for starting the project. Yeah, so right now we already started the project, so let's go to screen. Yes, and we will change this one to like this. Yeah, and we will copy from the screen, right? So edit, and then go here and then save as example screen 9. Yes, okay, and then free F2 for refresh the screen, and go here and then we can edit. Okay, so here is we can rename to scale real. Yes, scale of real, right? Can adjust. Yeah, and here is the high scale, low scale is the same as, yeah, integer, but this one we need to revise because we use the real, right? So let's go to browse the points. Yeah, start from SCL area, right? So SCL area high, yes, this one, and change this one to the real, right? And the precision example 2 or 1, yes, it's up to you. And one more for actually we can copy like this. Okay, I will delete this first, and then we will copy like this. Freeze, control and shift and drag and drop the mouse. Yes, like this. Yes, and this one just change to the ILO, right? So ILO, yeah, this one, and then the real value is the same, right? Because we copy from the top. Yes, and this one also, yeah, high scale output. So this one is the IHI, right? Here OHI, sorry, OHI, yes, real input value also. One more, yes, we can adjust to be aligned with the rectangle. And this one for the OLO, right? So OLO is the input also, and this one is the input value, right? So we can write in, right, input also. And the last one for the out, yes, so output, yes, this one is out, right? And we no need to tick the set point action because it just output. It will automatically generate from the input, right? So no need to adjust. Okay, so let's save our screen and then test screen, and we will adjust, yes, to be aligned with our formula or not. Yes, so example I will increase, yeah, right now it's 0. I will set to like this one. Yes, okay, so big, so I will adjust this one a little bit. So we can select all, yeah, and then like this, yes. And then we can create a new unit also. Example, this one is the bar, yes, or okay, example bar, color, yes, I will change to white color and decrease the font a little bit, yes, example 20, and we can copy, right? Press Control and Shift and then drag and drop the mouse, yes. Input value, this is no unit, right? And this one, example, this is a bar also, right? Or this one is the person, yeah, we can use the person also. So we will use bar first, yes, and test the screen again. So example, this one is the high and this one is the low scale, and high scale out, example 100, yes, and the input, right? Example input the middle, right? So like this, it will show the 50 bar, yes, 50 bar, because it's the middle, it means that 12 milliamp, yes, if we compare to analog input, 12 milliamp, and this one is the 20 milliamp, it will generate to the 100 bars, yes. So this is the instruction how to create the scaling block of the real data type, yes. Actually it's similar to be the same, yes, to be a integer, yeah, but this one is just real data type, and integer we can use from the tool chest, and for this one we create by ourselves, okay. So thank you very much for watching my video. If everyone have any question, please drop comment under my videos. I will reply soon. And I would like to request all of you to like, share, and subscribe my channel also to get more notification and more new video that I will create step by step. In this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about basic PLC GE, that we will learn about how to create function block of the scale real data type. It similar to be the previous video in part 18 about the create ladder, yes, and this parameter blocks that we already learned in the previous video, and we also connect it to the HMI also. Okay, so for today we will learn about the basic function block that we will create the one block for the scale reel also. Okay, and this is a formula. It the same as the previous video, but this is a function block. Okay, so let's go to our software for create the sample function block for the scaling. Okay, I will use the Proficy Machine Edition version 9.5. Yes, and this is a sample project. Yes, open the sample project. Yes, that we already learned in the previous video, so we no need to create a new project. So to create the function block, let's go to right click on block and then create a new folder. Yeah, FB scale example. FB scale here, it means that function block scaling real data type. Yes, so right click and then choose the FBD block. Yes, FBD block, and this is a block name, so we can rename. So scale SCL real. Yes, example like this, and we need to create some parameter, right, to be the same as this block also. In the previous video we learned about the block, but for the ladder. Yes, yes, here block SCL real. Yes, so we need to create the inputs and output, right? So let's go to parameter. Yes, for input we have 5 input, right? Yes, so first IHI. Yeah, IHI, second ILO, third OHI, fourth OLO, and the last one for input, right? And the data type is a real, right? So we choose real, or we can select like this. Yes, all parameter, all data type is a real. Yes, and this one we can comment. This one is the high scale input, right? So high scale input, low scale input. This one high scale output, low scale output, and this one is the input, right, value, and the last one for out, right? So out, and data type is a real also. Yes, So this is the output value, right? The result, and then click OK, and I will close this one first. Yes, and then go to the block and then double click, and I will zoom. Go to zoom, right? Example 250. Yes, too big, right? So I will zoom out a little bit. 200. Okay, so we need to create follow our formula. Yes, so first input minus low scale input, right? So minus sub, right? Okay, sub between input. Yes, between in and with the low scale input, right? So ILO, yes, and the next high scale, yes, high scale output minus low scale output, right? So minus sub high scale output. So OHI, right? Minus OLO, yes. Output high scale minus output low scale, yes. And one more for subs, right? High scale input minus low scale input, right? So subtract low scale input, right? So ILO high scale input, right? The formula. Okay, high scale input minus low scale input. So high scale input IHI, right? Minus low scale input ILO. And then this one should be multiply, right? So multiply, right? So we can write like this. Yes, and we will divide, right? Divide to this block. So divide, yes, like this. And the last one we add, right? Add to the low scale output. So add right, add to the low scale output, right? So OLO, right? and then the result is out. Okay, so that's all for create the SCADA, right? So we will call this block to the main, and then we will test. Okay, so save our project. Actually we can write like this: right click and choose the function block. Yes, and this is FB1 example, and we will call FB1 to the main, right? And then double click, and we will call this block to the FB1 block. Yes, so right click and then call. Yes, square real, right? SCL real, this one. Yes, I will zoom in a little bit. Yes, 1.5. Yes, like this, to be bigger than. Yes, so this is always on, right? So 7S, and this one we can use variable, or we can fix the value. Okay, so if I fix the value, example 32,000. Yes, dot 0, 0.0. Yes, and this one 100.0, this one 0.0, and this is input. We can choose the variable for adjust some value, right? So example SCL Air1 in, and this one SCL Air1 out. Yes, and we can validate. Okay, no error occur, and then we can download online and download. Yes, so right now when I adjust the input, example 16000, yes, it will show 50. Yes, because in the middle, right? So if everyone would like to use this block, you just call this block to use, right? So call. Yes, S, example this one SC SCLR1 R2, right? I. Yes, and we copy, and this one is ILO, right? OHI OLO, and this is in, right? And one more for out. Yes, and then we can download again. Yes, we can download again and adjust this rank, right? Example 100.0, example 20. So when I adjust the input, example 50, it will show 10, right? In the middle also. Example 100, it will show 20 for output, right? So if we would like to connect this block to the HMI, we can do also, right? So I need to assign some address for this one. Yes, example person A, right? View the reference address, right? Person A also. Person A, right? Person A. Person A also. And the last one is person A also, right? So we will download again. Connect, yes. And then download. Okay. So right now we already downloaded the program to the PLC, yes. And then let's go to our Cimplicity for create the new screen, right? For test this one. So open the Workbench and open the existing project, right? Yes, this one. Okay, and then create a new point, right? Many points, right? So I will create a new point. Like this. Easy to see the PLC also. Yes. So create the new points. Right click new, right? And I will choose the analog because we use person A, right? And choose the device. And this one example FB SCADA HMI, yeah, like this. And we will choose the real, right? For the data type. For device, we will choose the person A, right? So person A 6th, person A 6th, right? And we can duplicate because the data type is the same, so we can duplicate. So this one ILO, yes, and percent R 70. The next duplicate OHI, right? OHI percent R 72. Next OLO, right? So OLO percent R 74 and the input in, right? Percent R 76 and the last one for this one, right? So percent R 78. So out percent R 78. Yes. So we will create the screen, right, for write value from the HMI. Yes. So go to screen and then I will update the project and then start the project first. Wait a moment for starting the project. Yes. So right now we already started the project. Yes. And then go to screen 9 and then edit. Yes. Actually we can use this screen also. I will adjust the screen, yeah, and I will copy. So press Control and Shift and drag and drop. Yes. Okay, like this. I will rename this one to be scaling real FB, right, for function block. Yes, like this. I will choose this one. Adjust a little bit, adjust. Yes. If we freeze this one, adjust is so fast. If we freeze this one, adjust slow. Okay. So high scale input, low scale input, high scale output, low scale output, input value and output value the same, the same as the previous video. But this is just function block. So double click and browse the point, right? So browse the points. Go to FB, right? Because I start from FB. So first high scale input, right? So this one, and precision I will choose the one. Yes, this one also. Low scale input, right? So low scale input here, set point value action also. One more for high scale output. So high scale output, yes, this one. One more. One more for low scale output, right? So low scale output, yes, set point action and precision bond also, and this one is the input, right? So input value, this one, right? The last one for output, right? Router point and out, yes, this one. For this one, we don't need to tick the set point action because it is the output, right? It is the result only. Okay, so save our screen and then test. Yes, so we can adjust the screen, yes, like this, and choose this screen. So right now I will set the input high scale, right? Example 3200, yes, and start from 0, and this one for output example 100, yes. So when the input come here, yeah, example 1600, it will show 50, yes. Example a little bit, yeah, like this, it will show 7.8, and for the maximum, yeah, it will show 100%, yes. Example I adjust this one to 500, it will show 500. Okay, so this is the instruction how to create the sample block for function block and connect it to the Cimplicity HMI, yes. So thank you very much for watching my video, and I would like to request all of you to like, share and subscribe my video also. And if everyone have any question, please drop comment under my video. I will reply soon. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue our lesson about basic PLC GE, yes. And in the previous video, we already learned about the basic mathematics, that we already learned about scale real, but we create the function block, right? So in this video, we will create the scale real again, but we will use the SLT. It means that the structure text language. It the same the ladder and the function block also, but the structure text we write the code is very short, yes, but we can use the block also. Okay, actually we can follow this formula. You see how it means that the Q, yes, and the input, yes, it means that here, and uh, input low, yes, here, and output high scale here, yes, and output low scale here, and divide, yes, you see divide the high scale input minus low scale input. right? And then the final is plus low scale output. Okay, so let's go to our program to create the structured text language block and also connect to the HMI, right? So let's go. So today I will use the Proficy Machine Edition version 9.5 and the Workbench version 9.5 also for the HMI. So let's start with the Proficy Machine Edition first and go to existing project. Yes. Okay. And then create a new folder. Yes. STL scale. STL right? It means that structured text language scaling. Yes. And then I will choose the STL block. Yes. And for example, SCL real. Okay. Scale real. Yes. And we will assign the parameter for input and output, right? The same as the previous video. Yes. Let me open the previous video. Yeah. Here. So we need five inputs and one output, right? So let's go to our block and then go to parameters and then click here. Okay. So let's assign the parameter. First is the IHI, right? So IHI. The second ILO. The third OHI. The fourth OLO. And the last one is the in, right? So the data type is real. Yes. This one real also. Yes. All the data is real. Yes. And we can comment something here. For this one is the input high scale, right? Yes. Input high scale, input low scale, output high scale, output low scale, and this is the input, right? Input value. Yes. And one more for out here. Yes. So out, the data type is real also. Yes. And this is the output, right? It means that the result. So output. Okay. So right now we already assigned the parameters for input and output. Yes. So let's go to this block. Yeah. And then create. I will close this first. Yeah. Go here. Okay. So here I can zoom in. Yeah. And here we can comment something. Example, create scaling block for with STL, it means that structure text language. Yes, like this. And first we go to see the formula. Yes, our formula. So here is the formula. Yes. Then we will write the code to be the same as the formula, right? Like this. So out, right? Yes. Out. Out equal input minus input low scale, right? Colon equal, yes. Input minus ILO, right? It means that input value minus input low scale and then multiply by high scale output. So OHI minus OLO, then all is divided by IHI, it means that input high scale, right? Minus OLO, it mean that input low scale, sorry, output low scale. Okay, and then all is plus by OLO, it means that sorry, this one is the input. Yes, input high scale minus input low scale and then plus by output low scale, right? And this one, yes, and don't forget semicolon. Yes, so that's all for the code that we compare with the formula. Yeah, so let's close and then save. And if we would like to use this block, we can write to the main block, or we can create the new. Yes, example new letter. Yes, STL SC, example like this, and then call main, right? So call STL SC, right? And then double click. Yes, and we can write some command. Example scaling for analog input. Yes, and we can drag and drop this one to the main program. Yes, like this. And actually here we can fit the number. Yes, example for analog output, sorry, analog input, right? 32,000, yeah, 0.0 maximum, example 100%, yeah, start from 0.0, yeah, and this is the input. Actually input start from variable, right? So example SC1 underscore input, yes, and then this one SC1 underscore output, yes. So we can validate and download to the CPU for test. Yes. So if I increase the input, right? Example came from the analog input %AI, right? Example the raw data is 16,000, yes. It will show 50%, yes, right? And if the maximum, right, 32,000, it will show 100%, yes. Okay. So if everyone would like to use this block any more, we can drag and drop this block, yes. No need to create more. Drag and drop to use, yeah, like this. Example SC2 underscore IHI, right? SC2 underscore ILO, SC2 underscore OHI, SC2 underscore OLO, SC2 underscore input, and the output SC2 underscore output, yes, like this. So we no need to create the code more, yes, create only one time, then we can use this block. Okay, let me download and test. Example, the rank is the same, yes, and the output is the same also. Sorry, 100%, yes. Example, the input is, yes, 16,000, so it will show the 50% also. Okay, so we write the code is very short, yes, for this block. If we use the structure text, it means that we use the code is very short, yes, no need to create the long code, but we can use the same as the function block and the ladder block also. Okay, so we will connect this one to the HMI, right? So we need to assign the memory. Example %R, right? So go to view and then reference address, right? Yes. %R, yes. %R. But actually the analog input is the integer, right? So we can use converter from integer to real and then go to the formula. Yes. Okay. It's just example. Yeah. Okay, so let's go to our Cimplicity Workbench and then create the points, right? And then create the screen. So go to points, yeah, and then right click a new point, yeah, SC2 H IHI, right? So analog and use the real, right? Data type and then %R, yeah, %R 80. And this one we can duplicate ILO, right? Yes, ILO here. And %R 82. The next, duplicate again. OHI, right? %R 84. Duplicate again. OLO. %R 86. SC2, right? SC2 underscore input. So %R 88. And the last one for the result, right? So SCL2 input, right? SCR2 underscore out put. Yes. And %R 90. Yes. And then after the project and then start the project. Wait a moment for starting the project. Yes. Okay, so right now we already started the project. So let's go to screens and then right click and edit. Yes. I can use the geometry. Yes. For adjust the paper. Yes. So I will adjust to the width, right? Example 800, 1000. Yes. And this one for the LD, right? I mean the leather. And I will copy the function block, right? So I can adjust this one. Yes. adjust to be like this, and this one for STL, right? This one for FPD, yes. And this one for ladder, so I will decrease the font a little bit. Go to a line, yes. Okay, like this, and then we will choose the point, right? So browse the points and start from SCL2, right? SCL2, SC2, right? Start from SC2, yes. First is the high scale input, right? So high scale input, yes, this one. And we need to tick the set point action, yes, because we need to increase and decrease. Low scale input, right? So ILO, this one for OHI, right? High scale output. This one for OLO. This one for output, right? Sorry, for input. And the last one for output. Yes. And no need to tick the set point action because it is the result, right? So let's test the screen. Yes. Okay. I will zoom out a little bit. Yes. So if I put the high scale example 32,000, yes, and this one 100% example. So if the input, yeah, from analog input examples 16,000, yes, we will got the result is 50%, yes. If the maximum example 32,000, yes, we will got 100%. Okay. It to be similar with the function block at the ladder block, right? But the structure text we write the code is very short. Okay. So if we would like to use any block, we just drag and drop and then insert the variables and then we can use it. Okay. So thank you very much for watching my videos, and if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue our lesson about basic PLC GE, and it is the part 21st, yeah. And we will continue our lesson that related to basic mathematics, and the content is relational comparison. Okay, so first we will study about equal integer, equal real, less than integer, less than real, greater than integer and greater than real. Okay, and more of this block we can find in the two chests. Okay, here is the relational, so many functions that we can use. Okay, so let's go to our software to create the new block. But before go to the software, I would like to explain a little bit about the comparison. First is equal integer and equal real. Yes, it has two input. Is the integer or real values. Yeah, integer data type or real data type. It is the in1 and this is the in2. So if in1 equal in2, it will generate the boolean is turned on. Okay, it means that if in number 1 equal in number 2, the condition is true, so make the output is turned on. Okay, so here is the LT integer or LT real. It means that less than integer or less than real. It has in number 1 and in number 2 also. So if in number 1 smaller than or less than in number 2, it will the condition is true, right? So it also generate the output is on. Okay, and the last one is the GT integer or GT real. It means that greater than, yes, greater than integer data type or greater than real data type. So if in number 1 bigger than or get greater than in number 2, the condition is true also. Okay, so let's go to our software to write the block for test and also connect to the HMI. Okay, so let's go. I will use the existing project that we already learned in the previous video. Yes, so right click and create a new folder. Example relational, yes, relational comparison, yes, and create the new ladder block. Example, relational, yes, and go to the main program and then call, yes, so relational, okay, this pop, and double click. So here we can comment, yes, comparison of integer data type, yes, okay. So first we can drag and drop, yes. If we go to the ladder instruction of the tool check, we will find the relational, yes, you see this tab and then click here, yes, example equal integer, yeah, we can drag and drop, yeah, or we can write like this also, eq integer, yeah, eqint, yeah, like this, and this is the in one, so we can write some variables, yeah, example eq integer in one. I will zoom a little bit, yes, and this into, right, eq integer underscore into, and this is a coil, right, so it is the boolean, yes, it is the boolean, okay. So we can write the boolean variables, example in one eq into, yes, like this, in one eq into, it means that in number one equal in number two, yes, so we can download, yes, yes, you see now in one is 0 and in 2 is 0 and the output is true, okay. So if I write this to 1, yeah, 1 is bigger than or greater than 0, right, so the condition is false, okay. So if this one example 10, yes, it also false because in number 1 is bigger than in number 2, yes, so the output is false condition. If equal, yes, equal again, it will true again, right? Okay, so we will continue to the real data type. Yes, integer and real data type. Okay, so real, it similar to be integer, right? So we can write eq real and then enter. So here eq real underscore in1, eq real underscore in2, and here coil also, right? So in1 eq into real, yes, and we change this one to integer, yes, and then we connect and then download again. Yes, so right now it 0.0 for in1, and the in2 is 0 also, so the output is come true. Okay, so if I write this one to 20, yes, and this one to 25, the condition is false also, right? So if it not equal, it means that the output is false. Okay, so it is the example for relational comparison, integer data type and real data type, right? So let's go to less than integer and less than real, yes, and then greater than integer and greater than real. Okay, so we can copy this one and paste, yes, for less than for less than operation, yes. So less than, we can write lt integer, right? So example, in 1 lt into we can write lt integer in 1, right? lt integer underscore in2. So this is the output also for coil, yes. Integer lt integer yes, and we can write for real also, and then we download. Yes, so LT real, it is the real data type, right? So LT real in 1, LT real in 2, LT real Q, right? Okay, so we can save and then download again, and let's see the condition of the output. Yes, right now the output is false, both false. Yes, so if I increase this one to 1 example, yes, so the condition is come true because in number 1 less than in number 2. Okay, example this one to 50, yeah, it come false, yeah, and this one go to 50, yeah, it come true, right? 49 is also true, yeah. 49.9, yes, it also true. Okay, we can link this one to the HMI also, yeah, but we will go to the greater than first. Okay, so we can copy and write the command greater than, yes. So GT integer, right? So GT integer in 1, GT integer in 2, and this is the output, right? So GT integer underscore Q, and one more for real, right? So GT real, and this one is the GT real in 1, GT real in 2, and coil also for output, yes. So GT real underscore Q, yeah, and then we can connect and then download. Yes, now we see the condition is false because it equal, right? So if I increase the 1 to 1, yeah, or to 70, yeah, it come true, right? Yes, this one also real. Example 2.5, yeah, the condition is true. Yes, the condition is come false because the in number 2 is greater than in number 1. Yes, So it is very important for this block. If we compare everything, example, compare with the pressure or temperature to the some range, yes. So we can use this function to control the motor or control some interlocking, yeah. So we can use the comparison, okay. And it many functions that we can use in two chess, yeah. You see. So we will link this one to the HMI also, yes. So we can use the %A for link, right? So %A 92, %A 93, and this is a %M, yes. So I will link only one, yeah, because it's the same, yes. So I will save and then load again. Okay, so right now we already download to the PLC. So let's go to create the screen for test, yeah. We can adjust this one and let's see the condition. So open the Workbench file and then open the existing project. And then go to points, create a new points for analog, right? So EQ in one example, yes. And then the data type, yes, %A 92, and the data type is integer, right? Yes. And then we can duplicate for into 93, right? This one. And the condition, right? So right click new because it is the boolean, yes. EQ condition, yeah. EQ integer condition, yes. So boolean and %um 337, yes, %um 337. And then let's update the project and then start the project, yes. Okay, so let's go to screen and then we can use the existing screen, yes. Example this screen, and then go to save as, yeah. Screen number 10, yes. And close and go to screen and press F5 to refresh, yeah. So screen number 10, right? Here screen number 10, so we can delete some button. Yes, just keep only this. So if we config this one, yeah, so EQ, right, start from EQ in one, right, set point value also, and one more for EQ number 2, set point value also, yes, and I can write the rectangle and then color black, and then the, yes, like this, example 1.5, yes, and this text may be green color. Go to arrange and then go to the top, yes, and we can copy, control and shift, drag and drop, yes, and then change this one to in number 2. So this one for input number 1, right? So in 1 color, maybe I will use this color, yes, and copy for input number 2, yes, so if the input number 1 equal input number 2, the motor will change condition, right? Yes, so go to color animation and then edit for color, right? So condition, yes, and save and then test the screen, yes. Right now the condition is true, yes, because the in number 1 equal in number 2. If I adjust this one to 1, yes, the motor will change condition from true to false, yes, from green to red, yes. Okay, I will adjust this one a little bit, yes, center also, yes. Go to arrange, and we can group also, yeah, group, yes, we can make a group. Okay, so test again. So right now the condition is false because in number 1 is greater than in number 2, yes, and the function that we write the program is integer equal, yes, equal integer. So if the in number 1 equal in number 2, the motor will turn on again, yes. Okay, so I hope everyone will understand about this function after watching my video, and I would like to say thank you very much for watching my video. And if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my channel also to get more notification and more new videos that I will create step by step. So thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue our lesson about basic PLC GE, and the topic is basic mathematics. Okay. In the previous video, we already learned about the relational comparison, about the equal integer, equal real, less than integer, less than real, and greater than integer and greater than real, right? So today we will continue to part 22nd, yes, that we learn about greater than equal integer, greater than equal real, yes, greater than, sorry, less than equal integer, less than equal real, and comparison the integer and comparison the in real. Okay, so if we use the comparison for greater than equal, it means that if greater than, the output is true, and if equal, the output is true also, yes, that we call greater than and equal, yeah, or equal. For less than equal also, if the in 1 less than in 2, yes, or the in 1 equal in 2, the output is true also, right? Otherwise for CMP, yes, comparison, there are inputs, 2 inputs, right? For in number 1 and in number 2, if in number 1 equal in number 2, then the EQ is working, yeah, is turned on, because it is 3 function, yeah, we can call a 3-in-1 for this one. It should be have the one condition is true, yes, like the example 80 is greater than 79, right? So the GT, yeah, you see the condition is GT greater than is turned on right now. Okay, so let's go to our software to write the program and test with this block. Yes, so open Proficy Machine Edition 9.5. Yes, and then let's go to our project, existing project. And then let's go to comparison, right? Relational comparison. Okay, it is the existing video that we already learned. So we can control R for insert the row. Yes, insert the run. So command greater than or equal integer real, right? So we can write GE integer, yes, and this one GE integer in 1, GE integer in 2, and coin. It is the condition, right? So GE integer underscore Q, and one more for real. So GE real, GE real in 1, GE real in 2, and coin also, right? So GE real underscore Q, yes, and less than equal, right? So LE, so less than so less than equal, so LE integer, so LE integer in 1, LE integer in 2, and generate the coin also. So LE integer underscore Q, yes, one more for LE real, so LE real in 1, LE real in 2, and coin, underscore shoe, yes. And one more for compare, right? So comment, use CMP block. So CMP integer, right? So CMP integer in1, CMP integer in2, and this is a 3 condition, right? So while CMP integer LT, right? While also CMP integer underscore issue, so coil CMP integer underscore GT, right? Okay, so the real data type is the same, yes. So example CMP real, CMP real in1, CMP real in2, and coil, yes, CMP real underscore LT, yes, CMP real underscore issue, CMP real underscore GT, right? So we can validate. Okay, no error occur, and then we can save, and then go to target, and then download, yes. Okay, good. So we can see the condition, yeah. So we can start from the GE integer, right? So the condition is true right now because 0 equals 0. So the output is true. And if I adjust this one to example 57, it's still true, right? Because in1 greater than in number 2, yeah. Example this one 80, the condition is become false, yes. And the real is also the same function, example 2.6, 2.7, yes, the condition is changed. And for less than integer, yes, less than equal, it means that less than is true or equal between in1 and in2 is true also, okay. So right now 0 equals 0, so it generates to true. So if I adjust this one to 65, yes, it becomes false because in1 is greater than in number 2, and the real value also, yes, example 5.4, it becomes false. And if I adjust this one to 6.3, it becomes true. And for comparison, yes, example right now 0 equals 0, so the condition is turned on, yes. So if I adjust this one to 41, yes, it become true for GT greater than, yes, because in number 1 is bigger than in number 2, so this condition is turned on. So if I adjust this one to 42, yeah, this condition is turned on. For the real is also the same, yes. Example 6.2, yeah. I will adjust this one to 6.3, yeah. So the condition is changed, okay. So we can choose this block to the HMI, yes. I will use this block to the HMI and then adjust the value of in 1 and in 2, and then let's see the condition of the motor, yes. Okay, so I will disconnect first and then put some address, yeah, person A, yes, and this is person M, right? So person M, retentive true false, person M, yes, and then let's go to download again. Okay, so let's go to our Workbench, yes, and I will use the existing project, yes, right now it is running. So I will press the dynamic button to make the auto update, yes, but I no need to stop the project of Cimplicity, yes. So I will create the points, yeah, let's go to points tab and then right click in new. So CMP integer in 1 and go to analog and choose the device, and it is the real, right? So real, and then person A, right? Person A 94, yes, and we can duplicate in number 2, and then person A 94, 96, right? Okay, and this is a condition of motor, so we can create the point, yes, the boolean, right? And this is a CMP integer LT, right? Like this for this condition, and go to address person 338, right? And we can duplicate, and this is a EQ, right, for the middle, yes, 339, the last one for GT, right? So 340, yes, and then we can create a new screen, yes. I can edit and then save as screen number 11. Yes, and then freeze F5 to refresh the screen. Okay, we can edit to change the condition of the motor, right? So this one I can go to open group and then go to here, browse the point. So CMP, yes, CMP in CMP in one, right? So CMP in one, and then it is the real and set point value also, and the precision example 1. Yes, and close the group and open group again for into and browse the points. Yeah, in number 2 real also. Yeah, and 1 also for precision, and I will use this condition. Yes, example red color for I will choose another color. Example red color. Yes, red color. U for the greater than, right? So I can browse the points. So greater than, yeah, we'll change to red color, and one more. So I can duplicate, and this one we can use the equal, right? Equal is green color, and one more for less than, right? So less than LT, right? We'll see the yellow color. Yes. So let's go to test the screen. Yes. So right now it equal between in 1 and in 2. So if I adjust in 1 to 1, yes, it will show red color. And if I adjust this one to 2, yes, it will show another color. Yes. So we can use this point, this function to change some color. Yes, if we want, right? So I hope everyone will understand about my points that use the comparison or relational, yes, for control some the point, or we can also take this function to use another program, yes, for comparison. So thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my channel also to get more notification and more new videos that I will create step by step. So thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about PLC GE programming that focus about the counter. Okay, for mostly we use two types of counter, counter up and counter down. Okay, and one more for totalize. Yes. I would like to explain more about the counter for ladder logic. Here is the counter up. Yes, it means that when we provide the input, yes, here is in the input. If we provide the input, it will count from 0 to 1, 2, 3, 4, 5. Yes, and for here you see R, it means that reset. Example, if the CV show 20, yes. If we push the button reset, it will reset to 0. Okay. So if we set 20 like this, the output will turn on when the counter is count to 20. Okay. So if 20 equal 20 of PB, then the output is turned on. Okay, so this is a up counter. Another type we use down counter. So it not the same as up counter for down counter, because down counter when we first scan of PLC, it will start from 20 if we set the PB is 20. So when we provide the input for PAL input, the counter start countdown from 20 to 19, 18 until 0. Okay, and the output is turned on also. Yes, so it is the counter down. If we push the button reset, it will reset to 20. Okay. So one more time, we already use also for total line. Yes. Total line actually it has input. Yeah. Also, we can write T-sec. Yeah. T-sec it means that it will turn on and off, every 1 sec. And this is a RS. RS, and this is a HL, it means that whole. Yes, whole. And this is a total line. Yes, total line. And we can reset it for this one. And this is a not reset. Yes, cannot reset for this value. Okay. And this is a PB of total line. So normally we should have the PB. Yeah, it will continue counting if we provide the PB. Okay, so that called total line. So if we would like to clear this problem, we will go to write the sample program for test. First for up counter, second for down counter, and the third for total line. Okay, so let's go. So right now we will use Proficy Machine Edition version 9.5. Yes, for create the sample project, and I will use the Workbench, Proficy Workbench, yes, for HMI to link the data from the Proficy Machine Edition also. Okay, so let's start for Proficy Machine Edition first, and I will use the existing project that we already learned in the previous video. Okay, so wait a moment for open the project. Yes, so right click here and then create the folder. Yes, we can write to counter, yeah. Counter program, yes, counter pro, and we can use the ladder, yes, count, we can write count, yes, okay, like this, and don't forget call this subroutine block to the main program, otherwise it's not working. Okay, so call count block count, right? Okay, so first we will create the up counter, right? So I can write the command, yes, we are learning about PLC GE counter. Okay, so actually we can use the tool chest, yes, we can use the tool chest like the ladder, yeah, instruction. So here you see the counter, yes, it has three types, yes, first down counter, up counter, and then total line, yes. So first we will create the up counter, yes, up counter. So it is the input. Normally the input I use the NO contact, yes, for PAL for counting. So this one I can write up count enable, yes, up count enable, and here is the reset button, yes. So I will use the nominal open also. So up count reset, yes, up count reset, and this is the PV. Actually the PV we set to let the output is turn on, right? So example I set 10, yes, and then this is a name out counter, yes. So I can write counter 1, yes, yeah, counter 1, and this is a CV, yes, the CV, yes. So I can write counter 1 and score CV like this, and this is the output. The output is turned on when the count, yes, the counting equal the PV. Okay, so the output is turned on. So here I can write up count output, yes, up count output. Okay, I will zoom a little bit, yes, like this. Okay, so we can go to save and then download to our program, to our PLC, and then test for count up. So download, So wait a moment for first downloading. It is the basic program. So if we have the basic, we can do everything. Yes. Sorry. Start the CPU. Yes. Okay. Right now the CPU was started. Yes. So we can test it. Yeah. If I watch this one example watch, and I will use the watch also. Okay, easy to see the signal. Yes, so go to utility. Yes, and then drag and drop. First enable. Yes, second reset, insert counting. Okay, CV. Okay, this color easy to see. Yes. So actually we can monitor here. Yes, or monitor here. So when I press F12, you see the counting start count, right? Yes. F12 again, F12 on, F12 off, F12 on, F12 off. Until 10, the output is turned on, right? You see? Yes. You see the output is turned on right now. So if we continue to count, yes, the output still on, yes, it holds the signal. So if we press this button, it will reset to 0 and let the output is turned off. Okay, so it is the concept of up counter. Okay, so first when we provide the enable the input, it will count, yes, continue count until 10. It will enable the output and hold the signal, right? Okay, continue to count, the output still hold the signal. Okay, still on until we push the button reset. Okay, so it is the counter up. So we will continue to down counter. Yes, so I can copy command, or I can write one more for command. Up counter. Yes, and this is a down counter, right? So command down counter. Okay, so we can write like this, dn. Yes, dnctr, it means that down counter. Yes, and it is the input, so I can write no nominal open for input. So if we write the NC, we can also provide. Yes, okay, we can test NC. Yes, test NC. And for this button for reset, yes, I can write NO. So DN CTR underscore or ST, example reset. Yes, and this one DN CTR underscore in, it meant that enable. Yes, Example, I set 10 also for PB, and then counter 2, example, counter number 2, yes, counter number 2, yes, and this is a DN, counter underscore Q, yes. Let's see when I download the program, yes, which point difference between up counter and down counter. Okay, so let's see together. You see when I use NC, yes, it will maximum the number, yes. So we cannot use the NC, we can use NO, yes, for this context. So I will download again. So download. Okay, I will reset first. Yes, so it become 10, you see. For this one, if we download first time, it will show 0, but for this one it will show the same as the PV that we set. So if we set 11, it will come 11. Okay, so right now we can watch and start the counting. Yeah, it will count down from 10 to 9, 8, 7, yes. So when I enable this one, okay, 8, 7, F12, 6, F12, 5, F12, 4, yes, F12, 3, F12, 2, F12, 1, F12, 0, okay. So when it count to 0, it will provide the output is turned on. Okay, so in this section we can use the comparison, yes, that we already learned in the previous video for start the output, another output for compare, yes. Example like this. Okay, I will outline first. We can write like this. First, you see here is the integer, right? So we can compare integer. Example equal integer. Yes. That's why I show and share about the comparison before learning about counter. Okay. So example, I enable this one, and we can write like this. If counter equal 2, yes. Example equal 5 or equal 2, it let our output, another output is turned on also. Example dn eq 5, yes, dn eq 5, and then the output, another output is turned on. Okay, like this. Okay, download. You see when I enable, yes, reset first, yes, and then when I enable this one, and then you see 9, 5, 6, 5, yes, you see if the counting equal 5, it let this one turn on, right? Okay, So we can use the comparison to start another output. Okay, so actually we can use like this for control another output if we want. Okay, so let's go to our step about the total line. Yes, total line. Okay, so I can comment total line. Yes, total line. So actually we can drag and drop. Yes, so we can use the tsec for count. Yes, example tsec. Yes, tsec it means that turn on every 1 second. Okay, so it is the name. Example, I use the total line 1. Yes, okay, total line 1. We can press F1 for help. Yes, you see total line RS, it means that parameter RS. Yes, you see enable the function block. Yes, RS and the whole. Yeah, it is the whole for AL total line. Output reset and non-reset. Okay, for air we can reset, and NR we cannot reset. Okay, and this is a PV process variable for total line calculation. And this is a note, you see, if the value PV is less than the value of configuration parameter cut off, yeah, cut off, then the total line is do not increment. So be careful for use this function. You see, if the value of PV is less than the configuration cutoff, yeah, where is the configuration cutoff? We can watch for configuration cutoff. Yes, you see here. Configuration cutoff. Yes. Configuration cutoff. Let's see the hell again. Yes. Here. And if the PV is less than or equal the value configuration parameter cutoff, then the total line increase from the value of PV. Yes, it means it will start from the PV. Yes. Okay. So we can use the reset. Yes. Example NO total 1 total line 1 underscore RS, and this is the whole. Yeah, whole. If we want to hold the value that it total line, we can push this button. Okay, so total line 1 underscore HL. Okay, mean that whole. And this is a PV. Actually, we can use variable for this PV. Yes. Example, our slide. Let's see our slide. Yes. Here we can use another variable. Yes. Example, total 1. Total 1 underscore PV. Yes. And this is a reset value that we can use this button for reset. Yes. So we can use the reset total 1 underscore air. Yes, you mean that reset, and this is a non-reset. Yes, so we can write an air. Okay, then we check the program has error or not. Yes, so no error occur. We can download and then test to see the principal working of this total line. Okay, right now you see the total line is not count. All those I provide the PV example 90. Yes, you see not count because of the parameter is not correct, right? So if we would like to count this one, we must set the CT. Yeah, first set the CT is bigger than 0. Okay, CT or RO. Yes, example I set 1 and this one set 1 also. And also this one RO. Yes, you see the RO. Example I increase to 50 something. Yes, it's still not count, right? FC I increase. You see right now the total line is start count. Yes, so if I increase the PV, yeah, example 100, you see the counter is start count. Yes, start count. So if I freeze reset, yes, example I increase this one little bit. Yeah, and for this one default is 9999. Yes, like this. Let's see the health. Yes, for RO. Yes, you see it's rollover is default. Yes, 9999. Yes, 8 digit for 999. So we can write 9998 digit for default. Yes, you see right now it start counting and total line is have two. First is reset. So if I press this one for reset, yes, you see this one is come to 0, reset again, 0 again, but this one we cannot reset. Yes, you see start counting, and this one is a whole input. Example, we can push this one. Yeah, you see the value is whole, and turn off again, it will continue to count. It will calculate with the PB. Okay, so thank you very much for watching my video. If everyone have any question, please drop comment under my video. I will reply soon, and in the next video I will connect all this one to the Proficy HMI for test from the HMI SCADA. Yes, so I would like to request all of you to like, share and subscribe my channel also, to get more notification and more new videos that I will create step by step. Okay, so in this time I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about basic PLC GE that we will connect all this counter and total line to the HMI. We are using the Cimplicity Workbench. Yes. In the previous video, we already created the block of up counter, down counter and total line. Yes. And today we will connect some data or some value to the HMI. Okay. So let's go to our software to connect this data. Okay, first let's open the existing project. Yes. Here is an existing project that we will use it. And then let's go to main program. Go to see the counter. Yes, subroutine counter. Right. So we need to assign some parameter or some memory. Yes, to link to the HMI. Right. So it is the button. So I will insert the %m. Yes, and this is a button for reset also. So %m also, and this is the counting status, right? So integer, so %a, I will use %a, and this one also for counter up. So %m again, and this is %a. Yes. Also total line, yeah, total line %m, and this is %a, right? %a also. Yes. So it is the real and this is a real also for data type. Yes. So first we need to download after we assign the address to the PLC, and this is the output for counter up. We can also assign the %amp, right, like this. Okay, so validate the program. Okay, error 0, we can download to the CPU. Okay, so we need to create the HMI for this button, right? Okay, for count up the counter. Yes, and this one actually like this 10, right? First scan it will show 10. Okay, so let's go to Workbench project. Yeah, I already use the existing project also. Yes, so we will continue to our project. So first we can go to the points and create a new points, right, for this button. Okay, so let's click new point. It is the boolean, right? So boolean and divide. So example up ctn enable. Yes, up ctn enable. Divide %amp 341, right? So %amp 341, and this one also we can duplicate up ctn or st. Yes, up counter reset and %amp 342, right? And one more for up counter in output, sorry, up counter output, right? So we can duplicate. It means that when the PV equal if the counter equal PV, it means that enable the output, right? So this one up ctn output. Sorry, again. Up ctn output. So %amp 347, right? Okay, done for counter up for boolean. So we need to show this counter at the screen also, right? So we need to create the new points. It is the integer, right? So new analog, right, and divide also. So up ctn pv. Yes, so %r 98, right? So %r 98. Okay, and we can update the project and then start the project. Yes. We can also test one by one. So wait a moment for starting the project of Workbench. Okay, so right now it already started. Yes, so we can create the screen. Go to screen and then create a new screen example. And we can use the rectangle, yes, like this. Color, example this color, and we will use the rectangle again, right? Example black color, yes, and text we can use the yes like this for count up PV. So I will change color to green and text can write center, yes, like this. Yes, so we need to create the button for increase the counter, right, and reset the counter. So we can create the new button. Yes, increase, right, counter. Yes, increase counter. I will adjust the geometry to be 800. Yes, around 600. Then we can resign this one. Yes. Okay, this is a button for increase counter. Yes. So we can use the event mount up. Yes. And new procedure. Absolute set point, right? So set point up counter enable to 0. Okay, so we can config. Yes. Go to event. Go to mount up. New procedure. New absolute set point. Yes. And browse the point up counter enable set point to 0. Yes. And one more for event mount down. New procedure. New absolute set point up counter enable to 1. Yes. And this is a counter, right? So text browse the point ID. Yes. Up counter PV. Yes. It is the integer. Yes. set point no need, yeah, because it output. And we can save the screen, so CT and screen. Okay, so we can test the screen. Okay, so if I press this button for increase, yeah, you see the counter is still count, yes, counting. Okay, yes. If we would like to reset, we need to create one more button, right? So I can copy from this button, paste, yes. So this is a reset counter, right? So let config the procedure, go to procedure, and then this is the browse the point, yes. Reset, right? Or ST, okay. And we can copy, Control C, and then go to procedure number 2 and then paste, yes. Yes. And we can write some text, yeah. Example, sorry, text string, yes. Up counter monitoring, yes. Example, I change to yes, the color, and increase the size, right? Yes, like this. So let's save the screen and then test again. Yes, we can test for reset. Yes. If I would like to reset, I just press this one. Yeah, you see, reset to 0. Yes. Increase again. Yes. 2, 3, 4, 5, 6, 7, 8, 9, 10. The input is enabled. So we need to create the input enable, right? Output. Yes. So example, we have the counter enabled, so I need to use the cycle, right? Like this. Yes, normally it red color. If the counter enable, right? Output enable, it will show green color, right? So fill and then choose solid and choose the green color. Yes. So we can run screen again for test. You see right now it's green color. So if I reset the counter to 0, it will back to red color, right? Okay, we can up again, yes. Okay, for counter down, we also create like this, yeah. So first we can create the points, go to points, and then we can dynamic, yes. And we can duplicate for down counter enable, yes. So duplicate the end counter enable. So percent 3 for 3, right? Okay, and then for reset we can we can duplicate also dn 344, right? This one, and also PV, right? So PV we can duplicate from here because it integer also. So dn percent R99, right? And for output, yes, one more for output, duplicate dn, right? Percent 3 for h, and we also create for the total line, right? Sorry, go to points again, total line. For total line reset, right? Total line reset is boolean also, so we can use the boolean. Example, we can duplicate from this text. So total line rs, yes, percent 345, this one whole, right? HL, so we can duplicate HL, right? Percent 3 4 6, right? Sorry, 346, and this one for reset, right? Reset percent 345 for reset. Okay, recheck this one again. 346, yes. Okay, correct. And this is a real value, right? So we can new analog and divide, right? For PV total line PV, right? It is the real, right? So tick real percent R 100 and go here, data type is real, right? One more for R value, right? So duplicate total line underscore R 102, yes. And the last one for total line NR, yes. Total line NR, real also, yes. 104. Okay. So let's design the screen. Again, go to our screen, and then here I can copy for contour down, yes. Drag and drop by freeze control and shift, yes. Can copy like this. So we can change this text, yes. Down, counter monitoring, yes. Increase, it is the decrease, right? Decrease counter, and this is reset counter also, right? So we need to change the text. Yes, browse the point, go to browse, and then DN, right? Start from DN because it down counter. This one for enable. So this one copy, Control C, go to procedure number 2 and then paste. Yes, and here also reset, go to procedure, and we can write like this, DN. Yes, DN also. And one more for this one, so we can change to DN. Yes, this one also, go to color animation, DN, right? Okay, so we can test again. Yes, for counter down. Okay, here. So right now it shows 10, right? Here. So if I decrease, yes, 9, 8, 7, 6, 5, 4, 3, 1, 0. Okay, and the output will enable if the counter is count to 0. Okay, so we can reset also. Yeah, it's set like this, it will come to 10. Yes. Okay, the last one for total line. Yeah, here total line. So we can create the screen also. First is a PV, right? PV. So I can copy this one for total line. Yes. No, this one, right? Like this. And I can do like this. Yes. Okay. So this one should be total line, right? Total line monitoring. Okay, so first set point PV, right? So we need to copy this one more, right? Okay, like this. So this is the PV, right? So I can copy this text, PV R and this one NR, right? Okay, like this. I will adjust to be like this. Okay, to be center. So here we can use the RS and HL, right? So this is a RS. HL. Yes. And we can use the PV for set point value, right? And real. Example precision 1. Yes. So this one should be brown. And start from total line, right? total line for PV, right? So PV this point, yes, set point action also because we need to set point, and this one for brow again for PV, right? Sorry, for R, no need to set point, right? Because it is the output, and real value also one also, and this one real, yes, one also for precision, and this is the sorry non reset, right? Non reset, okay, no need to set point action, yes, because it is output also. So RS we need to configure this one. We need only one procedure, yes, so I can delete one procedure and delete one event for mount down, yes, and go to procedure and edit procedure. So here I will use the toggle set point, yes, one click it hold, right, toggle. So I can use the total line RS, right, and this one delete also, or we can delete this one and copy this one, yes, because it's similar. Should be count, right, total line RS, right, so total line HL, okay, can rename this one total line RS total line HL, right, like this, and save the screen, and we can test again. So first we need to enable this one, right, watch to be default, right, we can press hell, yes, F1. So first we set this one, yes, RO to this value, right, 9999 8 digit. So RO we will set to 999999 8 digit, yes, like this, and we will provide the PV, right, so we can provide the PV example 98, yes, you see the total line is start count, right, you see, if we provide the one more PV, yes, it's faster than before, you see, so it will calculate the PV from this, you see, automatic count. So if I press the hold, yes, yes, hold the signal, you see, it will hold and unhold again, not hold again, and this is a reset, yeah, we can reset this one, yes, and it will count continue when we not reset, yeah, okay. So this is a instruction how to link the data from Proficy Machine Edition of counter and total line to HMI Proficy Workbench. Yes. So I hope everyone will understand about my video and can do it. Yes. And I would like to say thank you very much for watching my video. And if everyone have any question, please drop the comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my channel also to get more notification and more new video that I will create step by step. Okay. For this time, I would like to say thank you very much for everyone and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue our lesson about basic PLC GE that we will focus to the parameter blocks. Okay, so before create the parameter block, I would like to explain a little bit about the benefit of parameter line block. Here is the block sample block that we will create after I explain. Yes, why we need to create the parameter blocks? Because you see this block is the same for input and output, but the name of the motor is different. Okay, so if we would like to use the same block with the other different name, we just create the parameter block to use with the control the motor, example start, stop, manual, auto, or other function that we can control. Okay, so if we use the parameter right block, we create only one block, then we can copy to use. Yes, it means that library, and here is the class. Yes, an object that we can define to use with the parameter right block. Okay, so to create the block, first we need to create the input parameter for this block, example MTR. Yes, it has three inputs. One is start input, stop input, auto command. Yes, and we will create the output for Q. It means that drive. When it turn on, it means that start the motor. And here is the manual auto control, and here is the name, that name array that we can link to the HMI by control from the HMI. Follow the names. Okay, and here is the some logic that we create for control this motor from the HMI. Okay, by using the name that I already saw before. Yes, so it is just example block. If we understand about the easy block like this, so we can make another block to control like the start stop control or speed control or everything that we can. Okay, so let's go to our software to create this block. Okay, so first open Proficy Machine Edition software. Yes, right now I will use 9.5. yes, version 9.5. And I will use the existing project that we already learned in the existing video, yes. To create the parameter right blocks, let's go to program blocks and then right click and create the ladder, yes. Example, this is a block name, motor CTL, example motor control, yes. And we need to create the input and output parameter, right? By go here and then click here, yes, to create the parameter. So first we need to input, right? Create the input the same as here, yes. Right now input we need to create start input, stop input, and auto command, right? So start input, str in, yes, stp in mean that stop input, and auto aut command, yeah. And it is the boolean, right? Because we just create the first block, so I will use the boolean first, then easy to understand. Okay, so this is a start input. We can write command also. Start input, stop input, auto command. Okay, and we need to create the output also, right? So output is Q, manual, auto, and name, right? Okay, so Q, it means that drive, A, auto, manual, and then name, right? So here is the boolean also, and this is the boolean also, and this one we need to create the word, yes, array. So word, and then I will use 3 word, yes. Okay, but actually we can use 2 word also, yes, because it just a little bit points, yes, to create for control. So I use 2 words, and this is a drive, right? Drive for run motor, yeah, and this is the manual, auto command, yes, auto on, right? Manual off. Okay, and this is the array name, yes, like this. So we can press OK, and then we can go to edit the block, right? For control start and stop the motor from the HMI. So let double click here, yes, and then we can choose the command. Example command create block for start and stop the motor, yes, like this. Okay, I will zoom a little bit. Okay, so first we need to extract the word name, right? So here is the word, right? Name, word. So we can control. Example, we would like to control the output from the HMI. So we can use name, yeah. Name 0 dot 0, yes, like this. And coil example for control the Q, yes, so we can control the Q output. Yes, and one more example, we need to use the select manual auto from the HMI also, right? So we can use the name 0 dot h0, sorry, h1, yeah, and use the coil MA, yes, manual auto. When we press this one on, it means that auto, yes. So we can write the block example, NO contact for start, yes, STRI, right, STRI, NC, STP, STP in, right, and coin, yes, for Q, right, output. So we need to hold the signal, right? So Q will hold the push button, right, input, okay. And we need to create the start stop from the HMI also, right? So we need extract the name also, example name 0 dot h2, yeah, coil. And we need to start stop from the HMI by using this coil to control this one, right? So parallel for start input also, right? So here we can use local variable by using this name of the block and then dot the variable name that we want. Example MTR motor control CTL dot, right, dot start, yes, motor CTL dot start, yes, like this. So we can use this start to parallel with the start input, right? So NO and motor CTL dot start, yes, like this. And one more for stop from the HMI also, right? So we need to extract the name also, name 0 dot h3, okay, and coil also. So here we can write motor CTL dot stop, yeah, and we can series with the stop button, right? So NC motor CTL dot stop, yes, like this. And we need to show the signal to the HMI also, right, when we start and stop, okay. So here let's go to see the slide, yes. We need to take the Q and manual auto and also start and stop to the HMI also, right, okay. And here when we select the auto mode, right, when we select the auto mode. So NO MA select, right? Auto mode select, then command auto, right? AUT auto command start, yeah, from the input. It means that start from here, yes, from here, and then it will turn on the motor, right? Okay, turn on the motor. Like this. But we need to interlock with the auto mode also, right? Okay. So here we need to use the NC contact for MA, right? Like this. If we would like to stop by manual mode, we can also put the stop here and then the manual here. Okay. So right now I need to write like this first. Yes. Okay, so we need to bring the variable like Q, MA, start and stop to the HMI, right? So we need to command take the variables to status to HMI. Yes. So first is the Q, right? So NO Q and then coil. For Q we need to use this one, right? Okay, so we can copy and paste, and one more for MA, right? So MA we use this one. Okay. And then we need to use the start stop also, right? Okay. So NO motor CTL dot start, right? Coil this one. Dot 2, right? And one more we can copy dot stop, right? Okay. And this one H3, right? Okay. So when we select to the auto mode, then we can control auto from the input. Yes. And we select to manual, we can start stop from the HMI. Okay. So let's validate the block has error or not. Yes. 0 error. Okay. So we need to close the block and then we can call, yes, this block to use. So I will use the motor control block, yes, and then I will call to main program. Yes, then go to call and then call the motor control. Yes. Command create motor control block. Okay. So we can drag and drop the block that we already created to use. Yes, by drag and drop. Yes, like this. Okay, like this. So we have input and output, right? You see start input, stop input, and auto command, and queue, and manual auto, and name, right? Okay, so here we can use like this example, motor 1 underscore str in, yes, motor 1 stp in, motor 1 underscore out com, yes, motor 1 underscore q or underscore dr, yes, motor 1 underscore a, motor 1 name, right? Okay, so here we can provide the percent W, yeah, example percent W, yes, like this, percent W1, yes, to link with the HMI, okay. Okay, so I will download, yes, download, right, okay. So here we can start and stop from the HMI, or we can use this one also, right? So let's see the block, inside the block, yes. You see right now is the manual mode, right? So we can start stop from the block like this. So when I push, yes, when I push button, this button start, you see the output is turned on, yes. Stop, it will turn off, yes. So it means that we can control to inside the block, yes. So if we have another motor like this, control like this, so we can copy, or we can drag and drop, yes. We no need to create one more, yes, just copy and paste, so we can use it. Example motor 2, yes, yes, motor 2 start input, motor 2 stop input, yes. So actually we can copy from this all and then just change to motor number 2, yes, copy paste, copy paste, copy paste, and change the name to motor 2, right? This one motor 2 also, right? This one motor 2 also, this one motor 2 also, right? This one more for motor 2 name, yes. And here we can provide the percent W, yes. Okay, it will start from 3 because we use 2 words for motor number 1, yes. So we can download again, and then let's start and stop to see, yes. And then we will create the HMI for control from the HMI also. And I will show how to create the class and object from the HMI, yes, during that time. So we can start and stop to see right now. Example, I start the motor 1, yes, start the motor 1. Yes, you see the motor 1 is turned on. I start motor number 2. I stop motor number 2. Yes. And then I will stop motor number 2 also. Yes. You see the function is working. So I will copy to create one more motor. Yes. Like this. Okay, copy. You can also copy like this. Yes. Yeah, copy like this. And just change to motor 3. Yes, motor number 3. Motor number 3. Yes. Motor number 3. And motor number 3. Motor number 3 name, right? Okay. So we can connect and then download. Okay, so we can test. Example, I start motor number 1. Okay, you see number 1 is turned on. Number 1 is turned on. Yes. Stop motor number 1. Motor number 3. Yes. Yes. So I will assign the %W also for motor number 3. Yes, like this. Okay, so this is the instruction how to create the parameter block for control the motor start and stop by using the parameter block. Okay, and I will show how to create the class objects from the HMI by using the Cimplicity Workbench that control for this motor in the next videos. Okay, so thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon. And I'm also sorry if I have mistake from this video because my English is not so good. And I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel General Technology Knowledge. Today we will continue our programming about basic PLC GE part 26, that we will continue our parameter write blocks. In the previous video, we already learned about how to create the block in Proficy Machine Edition, but we not yet create the faceplate or screen to control from the HMI. Okay, so today we will create the faceplate from the HMI, and then we control the motor from the HMI. Okay, to create the faceplate and screen like this, we will create the classes and objects. It means that library create only one, and then we can copy to use for 3 motors. Okay, so let's go to our software to create the class and object. So first open software Proficy Machine Edition. Right now I use version 9.5, yes. And I will use the existing project that we already learned in the previous video. Yes, let's see the previous projects. Yes, so we need to create the class by follow this box. Yes, so we can click inside the block. Yes, and let's check the name. Yes, actually we can follow the name that we already created in the parameters. Yes, here is the name that we will use for declare the parameters from the HMI to control the start and stop the motors. Okay, so we will use 2 words. So let's go to Workbench. Yeah, and I also use the existing project that we learned in the previous video also to create the faceplate. Okay, let's go to class and then create a new class. Example motor CTL. Yeah. And I would like to explain a little bit for the class attribute. Yes, for general we can use this default. Yes, but attribute we can change a little bit for the required and optional or hidden that we would like to hidden or choose the optional, or we can choose the required. For hidden, when we create the object, it will not show anything. If we choose the optional, we can fill the address or what you want, or we don't fill it is okay. But if we choose the required, it must be fill the box, otherwise we cannot create the objects. Okay, so for this address I will choose required. Alarm class optional. Device ID I will choose required also, and engineering unit label optional. Yes, and result ID I will choose the required also. Okay, so let's go to data item. Yes, data item. Actually the data item we can choose. Yes, we can create to be matched with the block that we want to control or show the status from Machine Edition to the HMI. Example, I would like to show the queue status of queue, yes, of output, control the manual auto from the HMI, or I would like to start and stop the motor from the HMI. So we can create it. Okay, so first we would like to create the start and stop from the HMI, right? So I will choose the name. You see the name 0.h2, it means that word 0, bit number 2, yes, for start. So we can create the data item, yes, follow this. So create the new, yeah, and it is the boolean, right? And divide point. Example, start. So it is the boolean. Description, we can mention example command start from SCADA, yes, and for device we can use the offset, right? Here is the word number 0 and bit number 2, right? So we can put the offset 2 and then go to expression and use the address adjust number 0 because it word number 0, yes, and then click OK, yes, and one more for stop, right? So stop name number 0 and bit number 3, right? So we can choose a new, or we can use the duplicate, yes, duplicate, it means that the same as copy. So stop, yes, and we can choose this one for stop, command stop from the HMI, yes, and we can choose the device and adjust to device offset 3, yes, because here is the word number 3, sorry, word number 0, bit number 3, okay, and one more for control the manual auto selection, right? So number 1, so we can duplicate, and this one for A, it means that manual auto, right? So we can go to general and change manual or auto mode selection, yes, and for device, let's see here, we can adjust to offset number 1, yes, okay, and one more for status of the shoe, right here. So we can use the offset adjust 0, yes, so duplicate shoe, offset 0 and the description drive for motor, right? Okay, so that's all for this item that we would like to control, start and stop, and show the status of drive output and manual and auto selection. So the last one, we can see the overall, yes, overall the name from the this box here, yes, name. So here I can use the new, yes, and choose the analog and choose the device, and this one is the array, or we can write name, yes, and I will use unsigned integer, yes, log array name, yes, and the length is 2. Okay, element is 2 because we use 2 words. Okay, let's click OK, and then let's create the object. Go to tab object and then click new, yes. Example, what is the code for our motor? Yes, the code is motor 1, yes, so we can choose motor 1, or we can use motor 100, yes, and here the description, motor 100 control, yeah, example, yes, and device ID is the device name, yeah, PLC1 that we already created in the previous video, and the base address is the address here, %W1, yes, %W1, and the resource ID is the, we can use here, class ID optional, so we no need to fill, yes. That's why I already explained about the optional or hidden or required, yes. Okay, that's all, and we should duplicate to 3 motors, right? Motor 100, 101, and motor 102. Okay, so we can create duplicate, and this one motor 101, yes, like that, and the address W3, right? So 101, we can change here the description 3, right? And one more for motor 102, %W5, right? So we can duplicate motor 102, yes, and we can change here to motor 102, and the address is %W5, yes, here %W5, it is the name of this block. Okay, so that's all, so we can start the project, and then let's create the screen for control this motor, yeah. So wait a moment for starting the project of Workbench. Yes. Okay. So actually when we start the project, we should see the point, yeah, the item that we already created in the class. Yes. So we can use these points, yeah, to create the screen for control the motors. Yes. So first I need to create the screen. Yes. Example, right now we have the start, stop and manual selection, right? So we can choose the go to object and then choose the motor. Yes, one motor that we want. Example, I will choose this motor. Yeah. Yes. And I will use the button for start and stop, right? So go to button. Example, start. Yes. Copy one more for stop. Yes. Actually the start should be blue or green color, right? Like this. And stop should be red color. Yes. And one more for the name of the motor, right? So I need to use the text string and choose like this. And here I can write some expression. Yes. But before write some expression, I will choose the manual and auto mode command first. Okay. So like this, copy. Example, manual mode. Yes, manual mode. Yes, use the manual mode. I will use the color. Example, this color. Yes, for manual and auto mode selection. Yes. Okay, good. So here I can use the group, select all and create the group. Yes. And I will provide the group name. Example, motor. Yes. Group name motor. Okay. So I can open group and then edit some expression. So the variables I should create also. Example, dollar object. Yes. And open group and then create the text expression. Yes. I will show the name of the motor 100, right? Motor 100 until 102, right? So here I can write like this, dollar object. Yes, dollar object. Okay. And for this one, I need to change the color of the motor, right? When the output is turned on, it will show the green color, right? So let's go to color. Yes. First go to color and then change to red color. Red color, it means that the stator of motor is not run. Okay, and when the motor is run, I will let change the color to green, right? So I can write the last object dot q, yes, because the data item we already create the q for the status of the drive, right, for a motor running. So go to field and then choose the color, yeah, to green color. Okay, and one more for manual and auto selection, right? So go to double click and then choose the event, right, for select the manual and auto. So go to event and then choose the mount up, yes, and choose the new procedure and then create new, and I will choose the absolute set point for this one. So this one, the last object dot MA, right, because on the data item we already choose the MA, yes, here is MA for manual and auto selection, right, and choose the 0, yes, and I will copy this one for create the new event, mount down and then choose the new procedure, absolute set point. I paste this one and choose to 1, right? It means that when I press the mouse down, it will set the manual auto to 1, right? And the program inside here will turn on. Okay. So when the manual is turned on, I will let this one show the status, so the text as auto mode, right? Auto mode, yes, auto mode, and let's check the font. Yes, for manual mode the font is Tacoma bold 36, yes, and this one I will change to font Tacoma bold and 36 also. Okay, so that's all for manual and auto selection. So to continue, we will create the start and stop, right? So here maybe I will choose the toggle set point is better than this, because we need to press one press, it will hold the signal, yes. So I will delete this one first and delete this one and go to toggle set point, yes, set point this one. Okay, but for start and stop we will need the pulse signal, right? If start, it will pulse the signal and then the program will automatically lock, yes, hold the signal. So let's go to start and then choose event and choose the mount up, new procedure, right, and new, and I will choose the absolute set point, yes, absolute set point start, yes. So the line object dot start, yes. The line object dot start and set to 0, yes. And I will copy this one and create a new event for mouse down and choose the new procedure, yes. Absolute set point again and paste this point and set to 1. Okay. So when we press the start, it will set to 1 and release, it will set to 0. Okay. The same, this one, go to mouse up, new procedure, new, and choose the absolute set point and the point here, stop, yes. So the line object dot stop and set to 0, and I will copy this one, create a new event for mouse down and then choose the new procedure, new, and absolute set point again and paste this point and set to 1. Okay, so that's all for create this faceplate, yes. Okay, like this. I will choose the color, yes, the color, yes. Okay, good. So if we choose the variable name, yes, motor 100, right, example. So when we run the screen, yes, it will show like this because we already configure the parameter, yes. And then we can yes, we can online and download to the CPU, yes. And then I will start and stop to let everyone see, yes. So right now you see the motor is turned off, right? So if I would like to on, I will start, yes. You see the output is turned on, yes. Stop, yeah. And if I select start again, it will turn on again, yes. And this is a manual auto, yes. This is a manual mode, auto mode, yeah. Manual mode again, auto mode again. You see the status is changed when we click. So we need to copy to 3 motors, right? So to create the copy, we can choose like this. So I will save the screen first. Yes. So I can copy like this. So right click, copy, and then go to the Workbench screen, and then I will create a new screen. And then go to paste and paste special, and then paste link, yes. Okay. And this one is motor 100. And save the screen, motor 100, yes. And I will close the one first and create a new screen and paste link again, yes. And change the name to motor 101, yes. And then save the screen again, motor 101, yes, and close this one, and then create the new screen again and paste again for motor 102, right? So change the object name to 102, yes, and then save the screen again. So motor 102, yes, okay. So we can press F5 to refresh the screen. So here we can run the screen one by one, and then motor 101, right? 100, yes, this one. One more 101, and one more 102, right? Yes. So we can open the screens and then control the motor one by one, yes. Okay. So when I press this one, you see this one is turned on. Press this one is turned on, yes. And press this one is turned on also. Okay. So I would like to stop. I can stop this one, yes, stop this one, yes. So we easy to create the faceplate for this software. So this is a manual auto control, yeah, auto mode, yes. And when we select auto mode, we can use the command, yes, for control the auto mode. I will turn on this one, yeah, and let's see the status is turned on. So I press F12, yes, and you see the motor is turned on, yes. Stop, yes. So this is a just example for create the faceplate, yes, for control the motor. It is a sample faceplate that we can create on the Proficy Workbench SCADA for GE. Okay. So I hope everyone will understand about how to create the faceplate, yeah, of the motor for control the motor like this. And it very easy to control and create, yes, class. So we create only one, you see, and we can copy to the many objects that we can create. Example, we have the motor, yes, I will show you. If we have motor 103 example, yes, so I can copy this block, yeah, and change this one to motor 103, yes, 103, yes, 103, 103, and 103 also, yes. and I will provide the address, yeah, %w7, yes. So I just download and then create the new objects, and then we can control the motor, yes. Okay, %w7, right? So I will duplicate, yes, dynamic first, and then duplicate the motor 103, yes. So motor 103, then choose the 103, and then %w7, right? Okay, w7, and then we can copy this project, yes, copy this faceplate, yes. So copy and just create a new screen, yes, and then paste the screen, and then change the name, yes, to motor 103, yes. Motor 103, and then save the screen. So motor 103, yes, and then we can control the motor, yes. So fast to create the block, and then we can control. Let's see. Okay, when I start and stop this motor, the new block that we already created will working. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop the comment under my video. I will reply soon, and I would like to request all of you to like, share and subscribe my channel also, to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about basic PLC GE that focus to parameterize blocks for create the scaling of analog output 4 to 20 milliamp. Here is the sample parameterized blocks that I already created, and here is the screen for example for explain to everyone. And in this section, I will include create class and objects for control the block also, yes. So let's go to our software to create the block. In this section, I will use software Proficy Machine Edition version 9.5 and Proficy HMI SCADA or Proficy Workbench version 9.5 also. So let's go to our software together. So first, let's open Proficy Machine Edition for create the parameterized blocks. I will use version 9.5 and I will use the existing project, yes, that we already learned in the previous video. already opened the project, so I will close one more. Okay, open again. So here is the existing project that we already learned in the previous video. To create the parameter right block, first right click on program blocks and then choose the language that we want. For me, I will choose the ladder, yes, and this is a block name, example AO. It means that analog output, AO scaling, yes, analog output scaling. And we need to put the parameter, right, before we create the block inside. So here is the description. We can put any command that we want. Example, analog output scaling. Here is the parameter that we will fill. So here is the input and here is the output. For input, I will use 3, yes. The first is input, second is high scale, and the third is low scale. And output, we need 3 parameters also. The first is output Q, the second is manual auto mode, and the third is the register array. Okay, for connect to the HMI, so we need to put the name or put the array name for link, yes. So before create the block, I will show the formula that we will use, okay. So here is the input, high scale, low scale, and output, right? Example rank from 0 to 100%, yes. And here is the raw data, actually from 4,000 to 20,000 for analog output module ALG264 something, yeah, we use 4,000, it means that 4 milliamp, and 20,000, it means that 20 milliamp, okay. So here is the formula, output equal 16000 multiplied by input minus low scale divided by high scale minus low scale and plus 4,000, okay. And here is the formula that I can simulation. Example rank from 0 to 100%, and if I put the input 10%, the raw data will 5,030 5,600, right? Okay, so if I put set point 50%, I will got 20 milliamp, yes, and here is the raw data. So example 75%, yeah, I will got 16 milliamp, and 100% I will got 20 milliamp, okay. So here is the formula, so we can create the block follow this formula also, yes. So I need to put the parameter for input, high scale, right, low scale, and this is the real, right? Because we need to convert from real to integer, right? Okay, real, and put the command input for auto mode. This one high scale, low scale. For high scale and low scale, actually we can change that we want. Example 0 to 20 ton, 0 to 50 tons also, or something that we want. Example, if I change this one 0 to 10, yes, example to 10. If I put 10 or put 5, I will got 12 milliamp, yes. And if I put 10, I also got 20 milliamp also. So this one is the high scale and low scale. So we can variable for this one. And this output, for output we will use 3 output also, right? The first one is Q, the second one is MA for manual and auto mode, and the last one for name array for link to the HMI. So this one is integer, right? And this one is boolean, and this one I will use bird, around 10 bird, yes. For this one is output with integer, yes. This one is manual or auto mode, yes. And this one is name array register, yes. So that's all. And then we can calculate by follow the formula in Excel that I already simulation. So before create the formula, we will use the selection, right? For select to manual mode or auto mode. Actually, when we select auto mode, it will just follow by the input from the block. Yes, this one. Yes, this one. If we choose auto mode, it will calculate from this input. And if we use manual mode, we can write from the HMI, and then it will calculate to milliamp. Okay. So this is a mode control. So create mode control interlocking, yes. So totally we have 10 array register, right, that I already put here from name 0 until name 9, right? This one, let's see. Yes, from name 0 to name 9. So if I use name 0, yes, example move real name 0 to I will create the local variable for manual set point from the HMI. Example AO scaling dot MA manual SP, yeah, it means that manual set point from the HMI. So we need to if we need to create the local variable, we need to write this name and then dot the local variable name that we want. Okay, so example AO scaling dot MSP, it means that manual set point. Yes, so I will use bit test word. Yes, and bit 1, and this one for freeze from the HMI also, right? This button manual and auto. So if I freeze manual or auto, so I will use this name, right? So name, this one we already used two array register, right, from 0 to 1, because it is the real data type. So this one will start from name 2. Yes, and if this one work, this one on, I will move real and then move input to the manual set point from the HMI, right? And then I will show the coil manual. Okay, yes, so the manual also, because it is the output also, right? Manual auto. Yes, we can click from the HMI for control. So if this one on, it will move input to the manual set point, and then we can take this variable to calculate our formula. Yes, so command calculation the scaling and convert from real to integer. Okay, by using formula. Yes, output equal 16,000.0 multiplied by high scale, input minus low scale divided by output, high scale minus low scale, and then all this one. Yes, plus 400.0, and then convert to integer, right? Okay, so we can follow this formula. So first we need to use the sub real, right? For so sub real input, right? So input minus low scale. Yes, input minus low scale then we need to create this one also, right, before multiply. So I will use sub real also, high scale minus low scale, right? So maybe I will zoom a little bit, zoom out a little bit, right? View zoom out, yes. This one is high scale minus low scale, right? So high scale minus low scale, then all divide, right? This one, so I need to use divide real. So divide this one and this one, then multiply by 16000, right? So mul real, yes, mul real mul by dot 0, yes, and then add real, right? So add real, add this result with 4000.0, and then convert this one to integer, right? So real to integer, okay, and then we will convert this one to integer and then output is 2, right? Okay, let's review the formula. First one is high scale minus low scale, input minus low scale, divide by high scale minus low scale, and then multiply by 16,000, and then plus by 4,000, and then convert to integer, right? Okay, so that's all for formula. So we need to take all this data, link to the HMI, right? So we can use command link data to HMI SCADA. So the first one is high scale and low scale, right? So I will move real for high scale, right? So high scale, and then this one is name 2, right? So we use only one word, and this will start from name 3. So name 3. For low scale, I will move real also, and this one low scale, and this name 3 and 4, right, for this block. So this one will start from name 5, yes, because it is the real data type, so it take 2 words. And then we need to link the manual set point, right, to the HMI also, this one, and the last one is Q, right? So Q is integer, so we need to move integer, and this one Q, and I will use name 7, right, because it is name 5 and 6, so it will start from name 7. One more for input, right? For input, I will move real, move input to name age, right? Okay, 8 and 9. So that's all for our formula and link the data to the SCADA. So let's check, validate the block has error or not. Okay, no error occur, so we can save our program and then go to create the block and then use this one. Okay, so I will create one more for block, example analog output, analog out, yes, and then go to the main program and then call this one to the main, and then double click, and then let drag and drop our block to use, yeah, for test. Okay, so it is the parameter block that we already created, so let's use it for test. Example AQ1 input, high scale example 100, low scale 0.0, and output example AQ1 underscore out. This one AQ1 underscore MA, and this one AQ1 name. Okay, so I will put %W for this address, yes, for register. So it will start from %W, yes, %W, or %N, it's up to you. For me, I will use %W, yes. So validate again and then download and then test. Okay, download to the PLC. Okay, so we need to create the screen from HMI or SCADA to control this block, right? Example set point from 0 to 100%, and let's see the output. Yes, to create the screen, let's go to HMI Workbench, yes, and then I will use the existing project that we already learned in the previous video, yes, and then we need to create the class, yeah. To create the class, we can go to the tab class, this tab, yes, and then right click and choose the new class, example AQ class. For attributes, we can use the format, or if everyone would like to change everything, example the engineering unit, no need to show, so we can hidden. Level we need to show, we can hidden also. And we can go to the data item. For data item on this block we have 6. The first one is input, the second one is high scale, low scale, and the name of array register and manual auto and the output, right? Because we need to control from the HMI. Example, set point 50%. The raw data should be like this, show like this, and we need to select the manual and auto mode. Yes. So we need to create the class. Okay. So data item, the first one, I need to create the name. For name is the analog and device. Yes. Yeah, here is the name, so I can write the last object name, and it should be integer and 10, right? Because we set 10 bird on the block. Yes. So click OK, and the next we need to create the high scale, right? So high scale is the visual and analog also. So high scale, yeah, it is the real. Here is high scale and real also. So we can write the last object high scale. It is the real and the visual tab. Let's go to choose the equal equation override or equation. Yes. The last object dot name 3, right? It is the name 3, so the last object dot name 3. And for the low scale, yes, we can duplicate. Duplicate. So low scale. This one, right? It is the real also, and the last object low scale. For visual, we can choose the name file, right? So the last object dot name file, and the next is the input, right? So input we can duplicate input. So the last object input, right? And it is the real also. So input is name 8, right? So the last object dot name 8. And we have Q, right? So Q we can choose the new because it is the output, and we choose divide and analog also. So it is the Q. So the last object Q, or the last object output. Yes, it is integer, right? And for device we can start from here and then choose the last adjust. Yes, address number 7. Yes, so 7. And we have also a manual set point, right? Name 0. So new MA, right? Or MSP. It is analog also, and it is the device. So the line object, manual set point, and it is the real, right, for data type. So real, and for device we use the line address adjust. So name 0, yes, it is correct. And one more for manual set point, right? Sorry, manual and auto mode. So new, it is boolean. So MA, the line object, manual, auto mode, right? And for device we use the line adjust number 2, right? This one. So name 2, yeah. So that's all for all parameters or data item that we already created. Yeah, so click OK. And the description we can provide here, example analog output class. Yes, if we write the description, it will go here. Yes, and update and go to the object, and then we will create the object, right? Follow this address. So %W9. So right click, we choose the class that we already created, right? This one, AO, and then we provide the object name, right? Example AO1 or AQ1. Yes. This one, AQ class, right? That we already created. This one, example analog output channel 1. Device ID is PLC1. Yes, that we already created. For base address here, %W9. Yes, start from %W9 and resource ID. Yes, we can choose this and click OK. Yes. So we will got the points, yes, that we already create from the class of data item. So update and then start the project. Before we create the screen for control manual set point from the HMI to the machine edition. Yes, so we need to create the screen more, and then I will show how to create the screen step by step. Yes, so if we check the point control panel, we got the point is online right now. Yes, so let's see here our description. Let's see the line object manual set point. Yes, the line object output. Yes, if we provide the name AQ1, it will got AQ1 manual set point, right? So if we have any example AQ2, yes, we will got AQ2. Yes, because we already fetch the line object inside the class item, right? Okay, so I will delete first for EQ2. So now we need to create the screen, yes, by using the object to control this block, right? So let's go to screen and then create a new screen. So first I need to create the library for this class, because in the next video we will use this object to create another block, example channel 2, channel 3, channel 4, yes. So first I need to create the library, yes. So if I save this one, example AQ lib, it means that AQ library, and then we need to create the text, example like this. Create the text one more, example mode control, and I need to have one button for manual and auto mode selection, right? Manual. I will change the color of text to be blue, right? Yes. And I need to have the set point, right? So I will use rectangle and then copy the text, right? Use one more text. Change to the green. Choose the font, example Tacoma font 16, yeah. And a rank to be center, yes. And for this one is set point, right? I use the arrow key for adjust. Okay. And we need to have the raw data show from output, right? So raw data. Yes. Raw data. Yes. And I will group this one, yes. So select all and then choose group, yes. And then I will provide the group name, example AQ, yes. And for this group I will use variable, so it is the dollar object, right? For this one we need to show the object name, right? So go to text and then go to expression and then use this one, dollar object, this one, and then close, yeah, because it will show the text, right? $object. Yes, and I will change the color of this one. Example color yellow, and the font should be 18. Example 18. Adjust to be center. Yes. So if we provide the object example AQ1, right, that we already created here, AQ1. Example, I put AQ1. Yes. And then test the screen. Let's see. I will got AQ1 here. Okay. Because we already fixed the object in this text. Yes. In here. Yes. So in the next topic, we will go to set point option, right? So we will set point from here if we select manual, and if we select auto mode, we cannot set point, right? So go here and then go to the text. Yes, and choose the object dot set point, right? So MSP, right, that we already created in the data item, and it is the real, and set point action and should be 1 for precision, and go to advanced. So it should be not the object dot MA, right? Because when we select auto, we cannot set point. If we select manual mode, we can set point, right? So not the object dot MA. Okay. And okay. Yes. And the next step, we will create the raw data that show from the Machine Edition, right? So click here and then go to text, and we can write the object dot q, right? And it is the integer, and no need set point. Yes. The last step is manual and auto mode control, right? So right now it show manual. So if we click the button, it will show automatic mode, right? We change the mode from the input, right? So go to the event and then go to the mouse up. Yes. And choose the new procedure and create new. I will use the toggle set point. Yes. And this one should be the object dot, yes, the object dot MA, right? So go to color animation and then go to the object. The object dot MA, right? It will show the text and translate text to automatic. Okay. And then I will adjust to be long, because when we press, it will change to the automatic. We will change this one to be green color. Yes, like this. So close the group and then save and then test the screen. Okay, good. So right now let's see here. We got 4000 from this output and it is the manual mode, right? So if I press this button, it will show automatic mode and it will got the calculation from this input, right? Example 50, yes. Let's see here, it is the 50, yes. So if I choose manual mode, I can set point, example 50, yes. 25, yes. 75, it should be 16 milliamp, right? And 100%, yes. It will show 20 milliamp, right? Okay. So I will revise the screen a little bit. Example, this one, it should be percent, right? So I open the group, open the group and then choose the text, yes. It is percent, right? Example percent. I will change to the white color, yes. Font, yeah, decrease the font little bit to 14, yes. So it is percent, yes. Or ton or kilopascal or bar that we want, yes. So it is just example. So run the screen again for test, yes. So we will got like this, okay. So if I change to manual mode, it will got the calculation from this one for output, right? Okay. So thank you very much for watching my video. And if everyone have any question, please drop comment under my video about how to create the sample block, parameter block for control the analog output. Example, this one we can use also. Example percent, right? Percent AQ. This one should be percent AQ, right? Example percent AQ 1, yes. So I download again, yes. Because it will connect to the hardware, right? If we have a module card, yes, like this. So if have any question, please drop comment under my video. I will reply soon. And I'm also sorry if I have mistake in this video also, because my English is not so good, yes. And in the next video, I will show and share to everyone about how to create one more object from this block for control the one more analog output scaling, yes. So in this time, I would like to say thank you very much again, and don't forget like, share and subscribe my channel also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to duplicate the objects or copy an object to many objects. Yes, that we can do on the Proficy HMI, and we can copy the parameter line blocks in Proficy Machine Edition. In the previous video, we already learned about how to create parameter write block of analog output scaling for to 20 milliamp in Proficy Machine Edition and in Proficy HMI SCADA. Okay, and we also tested simulation with the Proficy Machine Edition and Proficy SCADA also. Okay. So today I will show how to duplicate or copy an object or copy parameter write blocks to use with other analog output block. Okay, so let's go. So here is the previous video or previous project that we already learned about how to create the blocks for testing for analog output. Example, I set 75, I will got 16 milliamp, and if I set 100%, I will got 20 milliamp. Okay, so to copy the block for both Proficy Machine Edition and Proficy Workbench, we have two ways for copy. The first one is we can drag and drop the block that we already created in here to the main block. Yes, and the second we can copy from this one. Yes, so we can copy, right click copy and right click and paste. Yes, to use like this. We just change to example AQ2. Yes, and this one example 1 to 100% also. Yes, and this one Q2 also. Yes, AQ2 AQ2 name. Yes, and I will put the array address. Yes, for register example %W. Yes, and this one should be a %AQ, right? So %AQ. Okay, AQ2. And if we would like to copy another channel of analog output scaling, we can do like this, and we can change this one to AQ3. Yes, input. Yes, 0 to 100%, or this one example 0 to 100 ton. Yeah, 150 ton also we can do it. And this one example Q3, right? AQ3 AQ3 manual auto and AQ3 name, right? And one more, we can copy one more block. Yes, yes, example of Q for input, example 0 to 8,000 ton. Yes, AQ4. This one AQ4 also, and this one should be HQ4, yes, and the address of HQ3, yeah, we can provide %W, yes, and this one should be AQ, right, %AQ, and for this one also %AQ, this one %W, right? Okay, so that's all for created the parameter write block or copy and paste. Okay, so we need to download this block to the PLC before we duplicate the objects in the Proficy Workbench. Okay, I will show step by step about how to do it. Let's see here. So this one example 100 0 to 100%, 0 to 100%, and this one example 0 to 150 tons, or this one 0 to 80 8,000 tons. Yeah. So we need to change the unit also, that show here, right? Here we need to change the unit. Yeah. So if we would like to change the unit, I will add one more for description or unit. So let's go to the screen. Yes. Or we can create the object first. Okay. Example, I need to copy the object because we need to copy for objects. Yes. So we need to copy 3 object more, right? This one existing object, this one we just created. So to copy the object, let dynamic. Yeah, if we would like to no need to stop our project, please dynamic. Yes, make sure we already click the dynamic before we right click and then duplicate. Okay, so right click and duplicate. Example AQ2. Yes, this one should be channel number 2, right? And start from %W 19. Yes. Okay. One more for AQ3. So we can duplicate AQ3. So if we already created the class, we easy to create the objects, right? So we not spend a lot of time to create one by one. If we use class and object, it's very fast to create our plan. Okay, so this one should be channel number 3 and start from %W 29, right? Yes, and the last one start from %W 39 and AQ4, right? So duplicate AQ4 channel number 4 39, right? %W 39. Yes, so all of this is done for create objects. Yes, very fast. So we need to change the screen also, right? Because we not fit the unit here, so we need to change. To create the unit, I will provide the one more variable. Example unit. Yes, here. Example person. Yes. So if I change this one to like this, so we need to change the text, right? Expression like this. Unit, right? Yes. So let's test. Yes. So if I change this one to 10 example, so it will change to 10, right? Let's see. So this one should be like this. Take, right? Should be like this. Okay. Because we no need to fix it. We will adjust it or revise it follow the variables that we set. Okay. So I will copy this all screen to the screen of Workbench, right? So totally we need to have 3 screen more. So do like this. This is a library of screen, right? So to do that, please copy. Yes, can copy and go to the Workbench. Yes, and go to the screen and right click, create a new screen. Yeah, and make like this. Paste special and paste link. Okay. So if we change everything in the library, it will change to the another screen also, right? So this one example AQ2, right? AQ2 lip or AQ2 screen. Yeah. And we need to change this one, right? To the AQ2, right? The object name, and this one is the unit that we want to show here. Yes, so here. So we can provide example person. Yes. And we can test screen. Yeah. It will show person also, right? Okay. So we can save and then create the new screen and paste link also. Yes. Paste special and paste link. And this one should be AQ3, right? Object name. And this one for 10 example like this. Yeah. Okay, so we can save the screen. Example AQ3, AQ3 screen. Yes. Or we can do like this. We can save as the screen. Example AQ4 screen. Yes. And we can change the object name to AQ4. Example megapascal. Yeah. Yes. And we will got 4 screen, right? Here. 4 screen. So we need to use one more screen, right? Because it is the library. So I can right click and then save as one more for screen number 1. So AQ1 screen, and then I will change this one to AQ1. And example bar. Yes. The unit is bar. Yes. So right now we can open all the screen and then test with our block. Yeah. Example for screen number 1. Yes, here. Screen number 2 here. Screen number 3 here. Screen number 4 here. Yes. Okay. Oh, this one is not C, right? So I need to adjust a little bit. not see the unit, right? Okay, like this. So totally HU1, HU2, HU3 and HU4, right? So if I would like to test HU1, example manual mode, right? Automatic mode, manual mode, yes. I can write 25 bar, yes. I will got 8 milliamp, yes. Sorry. Yes, like this. So for HU2, we can do also rank from 0 to 100%, right? So let's click manual mode and then we can use example 10%. Yeah, we will got 5.6 milliamp. Yes, 50%. Yes, and this one 0 to 100 ton, right? So if I put 25 tons or 50 ton, yes, I will got 12 milliamp, right? 75, I will got 12 milliamp, yes. And this one 0 to 8,000, right? So if I put 4,000, I will got 12 milliamp also, okay. And if I put 8,000 megapascal, I will got 20 milliamp, okay. So it's very easy if we create the class and objects, so we can do the blocks or copy or duplicate to another blocks for the same process very fast. Okay, so if we not use the parameterized blocks, we do it one by one, it so a long time and we spend a lot of time for create it. Okay, so that's why we create the parameterized block and create the objects and class for do it. So it's just example for everyone that I already show about how to create the parameterized block in the Proficy Machine Edition software, or create the screen in Proficy Workbench software, and easy to create the screen. Yes. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like and share and subscribe my channel also to get more notification and more new video that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to use GE software Proficy Cimplicity HMI SCADA to open the screen or faceplate that we want to call by using the button. Yes. Example, I would like to open this faceplate. So I just click the button. I will got the screen or faceplate. Okay. Actually, if we have a lot of screen, we no need to click one by one to open. We just have the main screen and then we can call or open the screens that we want, just click only one button. Okay, so let's go to Proficy HMI SCADA Cimplicity software to know how to open the screen. I will explain step by step about how to use the procedure to open or overlay the screens. Okay, so let's go. Okay, first open the Workbench. I will use the existing project that we already learned in the previous video. Yes, let's see here. In the last video, I already create the screen of analog output. Yes, so today we will call the screen one by one by using the button. Okay, so first start the project. Yes, click start and click OK. Wait a moment for starting the project. Yes, because we need to run the project before we can use this project. Okay, so wait a moment. Okay, so right now we already started the project. So first create the new screen. Yes, right click and then new. Make sure you click here. Yes, click screens tab and then right click and then click new. Okay, and we can adjust the geometry. Yeah, if we would like to adjust something. Yes, example, I would like to got the width is 800 or 1000. Yes, like this. Yeah, and if I adjust the height to be example 600. Yes, we will got like this. If I would like to adjust to 500, yeah, we will got like this. And if we would like to adjust some color, let's go to color and then we can adjust the background color to be the color that we want. Example, this color. Yes, this color. Yeah, yellow color, or some color that we want. Yes, we can adjust it. Okay, and I would like to show some function here. First, snap visible. Yeah, snap if we have one object or one rectangle. If we draw like this, if we click the snap, we can adjust step by step very fast. But if we not use the snap, we can adjust a little bit. Yes, by using the arrow key of a keyboard, right, left, and up and down. Yes. Okay, click delete to delete the object that we want to delete. Okay, so if we use the button for call the screen, we can use like this. So let's click the button. Yes, click here and then draw. Yes, draw the button. Yes, like this. Example, open. Yes, screen AQ1. Yes, like this. When we apply, click apply, we will got the text that we write like this. Yes, and here is the button style. If we would like to use like this, yeah, it become use global, classic like this, and standard like this, and HP like this. Yeah, HP. If we would like to use the HP, yeah, Vista style like this. Yes, I like Vista style because very simple. Yes. Right, so if we would like to call the screen that we would like to open, yes, here example this screen. When I click the button, it will show like this, yes. So we can write it, yes. To configure the screen or call the screen by using the button, let's go to property, right click and property, and then go to event, yes, and then go to event name or event type. Mostly we use mouse up, yeah. When we click and release the mouse, it will action. Okay, so I will use mouse up and then go to action, yeah. Action, which action that we want, yeah. Example, use the script or use the new procedure. We can use new procedure and then click new, and here is the action type. Yes, example, absolute set point, open screen, next screen, invoke script, yeah, invoke method, yes, previous screen, overlay screen, open screen, yeah. In this section I will use the open screen, yeah, to show to everyone. And here is the screen name that we want to open, so click this one to browse the screen that we would like to open. Example AQ1 screen, yeah, we just click here and then choose the project name, yes, and click OK, and then we click OK again, yes, we will got it. So let's test the screen. So to test the screen, let's go to home tab and then click this one, yes, and then we can click to call the screen, yes. So if we click mouse up, yes, it will show the pop up the screen or first page that we want to open. Okay, so if we would like to open another screen, we just copy like this, yes, just copy, yeah. To copy the button, we can click Control Shift and then drag and drop the mouse, yes, to location that we want to copy, yes, and then release the Control and Shift and release the mouse. Okay, so we can go to text to change to the HU2, yes, and click event. It's the same event, right? So let's go to procedure, yes, edit the procedure to be screen number 2, right? This one, yes, and click OK and click OK again, and we can test. So right now we got two buttons. The first one open the screen number 1, and the second one to open the screen number 2. Okay, so if I would like to open the screen number 1, I just click here, yes. If I would like to open screen number 2, I just click here, I will got screen number 2. Okay, so we got two screens, the first one and the second one. Okay, and we can adjust the set point, yes. If we can open, we can adjust something, yes. Okay, so please do like this the same me to be button number 3 and 4. Yeah, so just drag and drop the mouse and click the shift and control on keyboard. Yes, like this, and then go to change the button name. Yes, button name to AQ number 3, and then go to procedure tab to edit the procedure to be screen number 3. Yes, click open and then click OK and then click OK again. For screen number 4, we can also do the same way. Yes, screen number 4, and then go to procedure and then go to edit the procedure and click the browse and use the screen number 4 and open and then click OK and then OK again. We will got screen number 4. Okay, so we can open screen number 1, screen number 2, screen number 3 and screen number 4 by just click. Okay, so this one, number 1, number 2, yes, and number 3. Okay, so it's very easy to call the screen that we want by using the button and using the procedure and event that automatic build in the software Proficy, Workbench, Cimplicity, SCADA. Okay, so I will adjust the screen to be small because we have only 3 buttons, right? Example 600, yes, like this. High around 400, yes. If we would like to zoom, just click Control, press Control and mouse. Yeah, screw the mouse. We will got the zoom in and zoom out. Okay. Okay, so we can use like this. Yes, like this. Can use like this, and we can arrange by select all. Yes, like this, and go to arrange and then arrange. Yes, to be good looking. Okay, so we can write the text, open the screen, right? Home, draw, and then this string. Yes, so we can write open the screen or faceplate. Yes, okay, and then we can save the screen to be a main screen. Yes, main screen. Okay, and then we can open again, test again. Yes, okay, screen number 1, screen number 2, yes, screen number 3 and screen number 4. Okay, so we will got 4 screen. If we would like to open some screen or more screen, we just do like this. So we will got the screen that we would like to open. Okay, so this is just basic about how to use the software Workbench, Cimplicity, SCADA to open the screen that we want to open. Okay, so thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to use buttons for overlay the screens, analog output screen. It is just example. Basically, we can overlay all the screen that we want to overlay. Yes. What is different between overlay screen and open screen? For open screen, we already learned in the previous video. We can open the screen one by one by configure the button on the action and the event. So we can open the screen one by one. Okay. But overlay screen, it means that we can overlay only one screen. If we would like to come back the previous screen, we can configure another event or procedure to overlay the screen back. Okay. So to open or overlay the screen, I will show how to use or how to configure the buttons to overlay the screens. Okay, so let's go. So first, please open the Workbench, Proficy Workbench. Yes, and I will use the existing project that we already learned in the previous video. Yes, and then click start the project. Yes. Okay, click OK to start the project. Because we need to start a project before we do something on this project. Okay, otherwise it will not work if we not start it. So please wait a moment. Okay, right now we already started the project of Proficy Workbench. Yes. So I will show the previous video a little bit. Yes. So here is the event or procedure for open the screens or faceplate. Example, we can click to open the screen. Yes, that we want. Yeah. Example, open screen number 3 and number 4. Yes, we can do it. Okay. So we did it on this procedure or event. So today we will create one more function that we call overlay screen. Yes. So I will create the main screen one more for overlay. Yes. So right click, make sure you click here screens tab and then click new. Yeah, right click and then new. Okay, we will got the screen. Yes, and we can save the screen and put the name main, example main overlay. Yes, main overlay. So here we can draw the button. Yes, to overlay the screen. Yes, example, click the button. Yes, so we can draw the button, the size of button, and we can configure the text button. Example, this one screen AQ1, yes, yes. So I will copy to be 4 buttons because we will overlay the 4 screens also. Yes, example like this. Okay, so I can adjust to be aligned. Okay, so I can use the text file. Yes, sorry. Just use the text string. Yeah. Example overlay the screen. So I can change the color of text to be yellow. Yes, and I can adjust the font to be 20. Yes. Okay, so right now we already create the text for the screen and buttons for the overlay the screen. So I will change this one to be AQ2, this one to be AQ3, and this one to be AQ4. Yes. Okay, and I can save again. To configure the button to overlay the screen, let's go to this one and right click and property. Yes, and go to event and then choose the mouse up. Yes, and choose the new procedure, new, and go to the action type. Yes, the action that we want is overlay screen. Yes, this one. So click here and then choose the screen that we want to overlay. So example AQ1 screen. Yeah, double click and then choose the project and then click OK. If we would like to confirm, we can also confirm. Yes. If I click confirm like this, okay, I will example. I will show. We will confirm. Yeah. If we do you wish to open the AQ1 screen.sim? Yeah. If we skip, it not overlay. If we click OK, it will overlay the screen AQ1. Okay. So we need to configure some button here to back to the main screen. Otherwise, we cannot overlay some screen. Okay. So I will configure the button to be AQ2 until AQ4 to be finished first. Then I will go to the screen. Yeah. AQ1, AQ2, AQ3 and 4 to be back screen to main screen. Okay. So I will not confirm. Yeah, we just pre here. If we would like to not confirm, yes. So for screen AQ2, we do the same method. Yeah, go to event and then go to mouse up, choose the new procedure and click new and choose the action type. Overlay screen should be overlay screen AQ2, right? Double click or click open and choose the project name. Click OK. Yes. For AQ3 screen, we do the same method. Yeah, go to mouse up, new procedure, new, and choose the overlay screen. Yeah, choose the screen that we want to overlay. Yeah, and click OK. One more. Yeah, we can go to event and then go to mount up, go to new procedure and go to action type, choose overlay screen. If we would like to overlay some screen, example we cannot find some screen, let's go to project location. Yes, and choose the project name and click OK and OK again. So right now that's all. We can save our screen and then can test. So if I would like to overlay screen AQ4, I can click here. We can overlay the screen AQ4. Okay. So I need to configure some button here to back to the screen. Yes. So let's go to screen number 1. Yes. To configure. So here I can draw one button that called main. Yeah, go to main screen. Yeah, yeah. I will decrease the font a little bit to be 14. Yes, yes. Example, this one overlay the screen main, so we can configure. Yeah, the same as the screen AQ1, 2, 3, and 4 also. So go to event. Yeah, I will change the color a little bit. Example, this color. Go to event and then go to mount up and choose new procedure and new, and then go to overlay screen and choose the screen name that we would like to overlay. So here is the screen that we would like to overlay. If everyone not find this screen, we can go to the project location. Yeah, example, my project is keep on desktop, so I will go to desktop and then choose the project name and go to screens, and we can choose the screen name that we want to overlay. Okay, so we can choose the screen. Yes, and choose the project name. Okay, save the screen and then copy this button to be paste another screen. Yes, paste screen number 2. Yeah, Control V and save. And for screen number 3, Control V and save. For screen number 4, please Control V and then save also. Okay, so I can close this screen also, and then we can test. Okay, so we will call the screen. Yeah, overlay the screen AQ1. Yeah, so it should be like this. Yes, and if we would like to go back, we can press this button. It will go to screen number 2. Yes, back again, overlay screen number 3. Yes, main again, overlay screen number 4. Okay, so we can overlay the screens that we want by follow the event and procedure that I already show. Yes, so thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon. and I would like to request all of you to like, share and subscribe my channel also to get more notification and more new video that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to open, learn from the sim demo of GE SCADA software, Proficy HMI Cimplicity Workbench. Okay. So what is the sim demo? Sim demo is the project that created from the GE SCADA developer that it automatically created after we installation the software Proficy HMI SCADA Cimplicity. Okay. And here is just example two screens that I took from the project of sim demo. Yes. And we can learn from sim demo such as we can create the points, create the animation or create the alarm of a process that we want, or create the trend view, yes, or alarm lock, alarm viewer, or data lock, yes. So many functions that we can learn from sim demo. And about this screen is the turbine generator that we can view the speed, the vibration, the percentage of fuel, yes, the pressure, yes, and many animation in this screen. Let me show after I explain about this. So to open the sim demo, let's go to our software Proficy HMI Cimplicity. Yes. So let's go together. Okay. So I already installed this software on my computer. Yes. So to open the sim demo, we can go to the C. Yeah. Try C program H86 for Windows 64-bit, but for Windows 32 bits we can go to program file. Okay, for me I use computer 64 bits operation, so I can go to open by go to this folder program 86 and then go to folder Proficy, go to Proficy Cimplicity, yes, and then go to projects, and we will see the sim demo here on the default folder. Yes. So to open the sim demo, let's go to this folder and then double click here. Sim demo is the Workbench project. Yeah. So we can double click on that file. So we will find the screen, we will find points, alarms, or many function here, example script also include here also. Yes. Yes. Okay. Let's see script. Yeah, here many script here. Yes, so we can learn step by step from here. Okay, and another ways we can open from here by open go to our program and then go to Proficy HMI SCADA. Yes, and then go to the Workbench. Yes, and then we can open. Yeah, click open and then go to C program 86. Go to Proficy Simplicity, and then go to project and then open the folder sim demo and then double click or click and then open the sim demo of Workbench project. So we have two ways to open the sim demo projects. Yeah. So to use or learn from this project, we need to start the project. Yes. So to start the project, let's click this button play. Yes. Click here and then click OK. Yes. So the project will automatically start until it finishes. So wait a moment for this project finish, and then we can use the screen such as simulation, open screen, overlay screen, or see some animation that has here. Okay. So here is many function. Yes, that we can learn. I will show after this project start finish. Yes. Example, let's see here is the trend view for temperature or from some point that we control. Example, the air house monitoring or generators, turbine. Yes, or some function here. Yes. So wait a moment for starting the project. Yes. Actually, we can learn this function. For me, I learned from this in the first time when I start learn about GE software. Yes, about SCADA. I learned from sim demo also. So today I will show how to learn step by step. Yes, from this project. Okay, so right now the project is already started. Yes, so we can open the screen. Yeah, example open here. Yeah, and let's see. Yes, we can go to another screen. Example power generator. Yes, so here we can start and stop. Yeah, the turbine. Example select to remote, and then we can start with confirm. Yes, let start it. Yes, right now it start. Yes, here let's see many animation. Example the pressure or the alarm. Yes, so right now it's running. Uh, so let's see how to configure this button or this pressure control. Yes, so we can go to check on the screen configuration, example, here is the screen of turbine, so we can edit and then see how to edit. Yes, I will zoom a little bit. Yes, so last time this button has confirmed, right? So let's go to see the event. Yes, event, turn off the motor, right, with the confirm, and then we can go to see the edit procedure. Yeah, let's see, here is the point. Yes, point ID, so we can copy this point to search on the points. Yes, here. Yeah, and how to see this point. Yeah, let's see, double click to see the point. It is the resource ID and it is the visual point. Yes, because we not connect to the PLC, so we use the visual point. Yes, initial value 0. Yes, so it is the boolean, and then we here absolute set point. Yes, it is the event and action to start, and then here let's see, it is confirm also. Yes, edit procedure. Yes, like this, confirm to start the turbine. Yes, so we can copy this point and then go to here and then search. Yeah, let's see, it is the boolean also, and it is the visual point. Yes, so many function here we can learn from this project. Yeah, example, configure the animation of color green and red. Yes, let's see, here we already started the turbine. Yeah, and also we can stop also confirm. Yes, stop the turbine. Yes, and we can go back to the brewery. Yes, like this. Okay, let's see, here it's many animation. Yes, example auto. Yes, let's see how to configure this animation. We can open this screen to see also. Yes, it is the motor. Yes, it is the auto. Yeah, example like this. So it is very important that we can learn from sim demo. Yeah, that are the so yeah, automotive. Yeah, like this. So we can auto mode. Yes, and then we can start, and it will work for animation. So we can learn from here also. So thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon. And for this video, I just would like to show how to learn from this project for basically only. Okay, if we know about the basic, we can create the project by ourselves. Yeah, and then we can copy a little bit from here, or we can learn from here to apply to our project. Okay, so thank you very much again, and don't forget like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to read data from power meter Schneider PM 5350. And here is the PLC GE, and here is the serial communication, and here is the power meter that I already connected cable from power 220 to the power meter. And here is the connection between power meter data to the serial port. Here is the data terminal of a power meter that we should connect follow the manual operation. Example, if we use the RS 232 data, we can wiring follow this step. And if we use RS485 or RS422 to wire, we must follow this step. And if we use RS485 or RS422 for wires, we can follow this step. Right now I use RS485 2 wires, so I need to follow this step. And here is the terminal connection. For TH minus and RH minus, I use terminal number 2 for female of LAN cable. Yes. And for the power meter side, I will connect D0 minus here that already stick on the nameplate. And for ground, I will use pin number 8 for this one. And for data plus of a power meter, I will connect to terminal number 1, yeah, here, and pin number 4, yeah, it is the jumping connection. So we need to configuration for this module to link from the serial port of PLC GE to link with the power meter. Okay, and I will use the Proficy Machine Edition version 9.5 to configure the hardware configuration between PLC GE and power meter. Okay, so let's go to our software to do the configuration. Yes, and test with show the voltage of AN, BN, CN, and frequency. Yes, so let's go to our software. So first open software Proficy Machine Edition. Yes, and I will create a new project for this mirror. Yes, so create the new project name example power meter, and I will create the empty project. Okay, I will add the target for PACS system, air 3i, yes, and it is the target name, example power meter, yes, and we need to configure the CPU and power supply and Ethernet module for communication, right? And also the serial port for communication between power meter and the serial port. Okay, so first I will use the power supply, this one, yeah, so I will replace it. And for CPU I use slot number 1, and I use CPU 310, yes, so I will replace it. Okay, so this is a CPU setting example, the power up mode I would like to run, yes, and this one I will use always plus, yes, scan, yes, I will use a constant window, and it is the memory, yeah, example I use 3000 for analog in, 3000 for analog output, and for register I will use 32,000, yes, center view I will use 32,000 also, yes, and for IO bit I will use 32,000 also, yes, 32,000 also, yes. Okay, so that's all for CPU memory setting. And for slot number 3 I will use Ethernet module, yes, slot number 3, because slot number 1 and number 2 we already use for CPU, yes. So I will add communication, yes, for Ethernet module, so ETM, yes, IC 695 ETM001, yeah, Internet interface module, click OK, and then I will use true for variable mode, yes, otherwise we will use %i, so I don't want use %i, I will use variable mode, yes, so map the address, example node 01 slot 03 ETM, yes, and it will use HT bits for status, yes, and for the IP address I will use 192.168.0.100, yes, and subnet mask 255.255.255.0, yes. Okay, that's all for communication. And then I will go here and then property, and then I will set this one to be 192.168.0.100, yes. Okay, and for slot number 4 I will use IC 695 CMM002, yes, so we must add it, so right click and then add module, yes. So this module is the communication, yes, this one, yes, there are 2 ports and 4 ports. If we use CMM004 we must select this one, but right now I use CMM002, so I select this one and click OK. So wait a moment for insert the module. Yes, and for this one we also can use the variable mode for status. Yes, so I click true. Yes, so setting. Yes, so go to the terminals for this module, and then we can write the variable. It is the output, right? So I will scroll to find the input for port 1. So right click, map variable, example CMM 002 in, example in for port 1. Yes, like this, and we will use address. Yes, 224, right? So 224, and for output port 1 we also can write CMM 002 underscore in, out port 1. Yeah, and we use the array of output 1 to 8, right? So 1 to 8. Yes, and for port number 2 the same. Yes, so CMM 002 in port 2. Yes, and we spend 224 also. Yes, yes, here, and also output, so CMM 002 underscore out port 2. Yes, and we will use 128 also. Yes, okay, good. So to link with the power meter, I will use port 1 or port 2. Okay, so right now I will disable port 2 first and use the port 1 for communication between power meter and this serial port. Okay, so I will enable for port 1. Yes, to be mode bar master. Yes, okay, and I will use the baud rate 16.2 kilobyte. Yes, and I will use event for priorities and stop bit 1, delay 100 milliseconds. Yeah, and I will use RF for 85 2 wise. Yeah, the same as the slide that I already mentioned. Yeah, I will use this one. So we select like this, and then the drop bit. Yes, we can set 0. Yes, okay, and for user ID, it means that the power meter, yeah, ID, I will use number 1. Yes, and then go to the, okay, this one is very important. If we config is incorrect, we can not communication between our power meter and PLC serial port. Okay, so very important. So I save the project first, and then let's go to the this one. Yes, port data for port 1, because right now I disable the port 2 first. I will use port 1. Yes, so we need to know the manual operation of power meter before we can configure this one. Yes, So I will open the data of power meter, yeah, for this model. Yes, this is data of power meter PM5350 address. Yes, example frequency we use address, yeah, UD address, and it is the unit, and we will use 2, yeah, for integer 16, yes, and flat 32, and this is the range of the frequency of the power meter around 42 to 70 hertz. Yes, okay. So I will use this one for it also, because right now our power meter is show also. Yes, and the next I will use the volt. Yes, it's so many data, so we can use, yeah, but I will show a little bit for this link. Example voltage and frequency that we can show, yeah, all this data we can use, yeah. So I will find volt, yes, this one, yes, or we can search the address, or we can check like this. We can search voltage. Right now I remember the address, so I can search 50022. Yes, cannot find, right? Voltage, frequency, yes. So wait a moment, I will show the voltage address, yeah, that we will use. Voltage, current, right? I will close and open again, and we will search. Yes, okay, this is the volt, yes, volt address. We can read from volt AN, BN, CN, and LL, and also LN also. Okay, so we will start from this address, yeah, and the same as frequency, yeah, use the flat 32, and it has a rank also, yes. Okay, so we need to follow this one. So first I will read vol for AN, BN, CN, and vol LN, yes, because right now I just connect, yes, this one, yes. So we can use this address to configure our software, yes. So first I will enable this one to read continue, yes. We have many functions that we can use. So I would like to read the volt from power meter to our software, right? So I choose read continue, and this is station 1. It means that the power meter address, yes. So if your our power meter address number 2, we can set number 2, yeah. But right now I will adjust the address of power meter to number 1 first, yes. I will show after configuration, yes. And then this one I will use holding register, yes. And I will start from %I, yes, %AI, sorry, %AI 01. And this is the address that we want to read. It means that the address of meter, okay. So if I would like to use read the address of read the data of voltage. So I will start from this address. Okay, so 500 and 22. Yes, 500. So this one 50022. Yes, it is the address, and I will start from AI1 to length. Yes, so if we would like to use this one, we need to use one value we use 2. So if we use like this, we can use 10. Yes, 10 register. So I will put length 10. Yes, 10 register. Okay, okay, that's all. And then we can download this project to the PLC. Yeah, but before download, let's check our power meter first about the address. Yes, for this one, otherwise it will not work if the address is incorrect. Yes, this one, and it will affect to be this one also. Yes, so let me show how to change or how to check the baud rate of power meter. Yes, so if we would like to check the address of this power meter, we can go to this one. Go to main. Yes, and go to setup, and password is 000. Yes, and then go to the communication. Yeah, COMM, and we can check. Yes, right now the address is 1 Modbus. Yeah, and it is the baud rate 19.2 kilobyte. Yes, even. Yes, so that's all. It correct to be our configuration on PLC. Yes, and right now voltage show like this, and for frequency I will show later. Yes, frequency, yeah, we can hear around 60. Yeah, frequency 60 hertz. So we can back to the work. Yes, okay. Okay, so right now we already checked the power meter is correct with the address. So we can download. Yes, so save, and then can download the project. Before download, let's check the ping 192.168.0.100. Yes, because I already set the temporary IP for this Ethernet module. Yes, so it is okay. We no need to set anymore. And right now I already connected the cable from my PC to the slot number 3 of Ethernet module. Yes, this one. So we can download. So online and then download. Yes, right now we can online, and then stop the CPU first before download. Yes, and then I will download the configuration. Yes, our configuration to the PLC. Yes, wait a moment for downloading. Okay, So right now we already download successfully. Yeah, complete. And then I will start the CPU. Yes. Okay. So first we can go to person AI 1 to check the data. We can link or not. If we got data, we can say that we can communication between PLC and power meter. Okay. So let's go to here and then go to AI. Yes. Okay, so right now we got the data. Yes, we got the data from person I1 to person I10. Yes, so it means that we can link from power meter to our software. Yes, here. Yeah, this address. So we need to show it is the raw. Yes, raw value. So we need to convert this value to show the voltage or frequency, right? So let's go to main program. Yes. Okay, I will offline first and then go to the main program. I will create the block. Yes, for show the voltage. Yes. So first I will move word. I will move from person AI1 and I will create one variables that call I will use data type forward. Example PM01 volt take. Yeah, and I will use two words. Okay, so I will move this one to word number 1. Yes, so PM voltage 1, right? And then move one more word. Yeah, from person AI to, yes, to word number 0. Yeah, voltage, right? This one, number 0. Yes, and then I will move here. Okay, move the PM. Yes, this one, and I will got the voltage of this power meter, right? So I will got voltage AN. Yes, so example AN, volt AN. Yes, voltage between phase A and natural. Okay, so let's test. I will download. Yes, to test. Okay, okay, right now it show around 226 volts. Yeah, so I will show the here also. Yes, counter. Yes, let's see voltage AN around 226 dot something. Yes, Okay, so thank you very much for watching my video, and in the next video I will show any phase for voltage A, B, N, C, N, and frequency, and also connect this one to the Proficy HMI SCADA also to show the volt or frequency. Okay, so I hope this video just example for if everyone would like to read the data from any power meter, we can follow this one. Yes, and if I have mistake in this video, I would like to say I'm sorry. Yes, and we will see you next video. I will show another function that can link. Yes, and also show on the HMI. Yes, so I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next video part 2. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today let's go to part 2 of Proficy Machine Edition for read data from Schneider Power Meter model PM5350. Okay. In the previous video, we already learned about how to configure the hardware configuration of PLC GE and connecting the cable from power meter to the serial port. Okay, and already configure and test phase A and for power meter to show on software Proficy Machine Edition. Yes. So today we will continue to part 2. Yes. For how to connection and how to configuration the hardware, we already learned in the previous video. So in this section we not discuss anymore. So let's go to write the program for show or read the voltage from BN, CN, and also frequency. Okay. So let's go. So this is a previous video or previous project that we already learned and read the phase AN from the power meter to show on our software. Yes. So the project is will start from %AI1 to %AI10, right? Let me show the hardware that we already configure. Yes, here it will start from AI1 to AI10, and here is the address of power meter that I already show on Excel file. Yeah, this one. So we need to use this address and this address. For this address, I'm not yet connect the cable to the power meter, so it will show 0. Yeah, let's see. Here, no data, right? Because I'm not yet connect the cable. Yes. So we will read the data from this phase BN, right? Yes. So to read, let's go to the main program, and then we can write command a little bit. Yes. Example command read voltage A N from, it means that face A N, yes, face A and natural power method, yes, okay, and then we can copy, yes, actually we can copy this one, yes, and paste, and this is a BN, right, face B and natural, yes, and for face B it will start from AI3, yes, AI3 to AI4, right, two words, yes, so I will start from percent AI3 and percent AI4, yes, and this is the same, yes, and here is the vol AN, but we must change to vol BN, right, so let's change this one to B, yes, BN, yes, and we also read data from the CN also, right, Facy and natural, yes, so we can copy and paste, so CN, yes, and CN it will start from percent AI, right, this one AI5 to AI6, yes, so I will start from percent AI5 and AI6, yes, and I will change this one to CN, yes, and for L and L average, we also can write the program, but will not show the data because I'm not yet connected cable, okay, so we can write L and L, yes, okay, so copy and paste, so this one it means that line to line, yeah, L to L, yes, and it will start from percent AI7, right, and earn AI 8, and this one should be LL, yes, vol LL, yes, and the last one it should be right, should be L and N, right, yes, line and natural, yes, so we can comment line and natural, and it will start from percent AI9, yes, until percent AI10, right, okay, and we will change this one to be vol ln, yes, okay, so we can save the project and then download, yes, download the program to the PLC, and let's see the status, okay, okay, right now let's see face A and N, B, N, C, N, and also LN show the value, yes, and I will show on the power meter also, yes, the same or not, yes, okay, let's see here, it's the same, yeah, between AN, BN, and CN, yes, and average the wall between L and N, okay, the same as in the PLC show, yes, here. Let's see, it's the same. Yes. So it means that we can read data from the power meter. Yes. So in the first step, we need to read the frequency, right? Yes. We read frequency also. This one, yes. We will read this one to PLC also. Yes. So to read the frequency, we need to configure the address, yes, of power meter also, yes. Okay. So for voltage, we already read, yeah, we can read, and the voltage between power meter show and the PLC is the same. Okay. So right now we will read the frequency. Yes. Okay, I will outline first. To read the frequency, let's go to config on here. Actually, we have like this, yeah. And then we go to hardware, and then go to double click on CMM002, yes. And then go to port 1 that we already config, yes. But we must know the address of the power meter first, which address that we will config for frequency, right? So let's go to check the frequency. Mostly we can also search frequency, yes. Okay, here I already mark, yes. So frequency, it will start from address 3110, okay, 42 to 70x, yeah. And the data is the same, so we need 2 words, yeah. So the address we must remember and go to configuration, yes. And then data exchange number 2, I will enable to read continue, yes. And then this one I will use the holding register also. And here is the address that we will put from power meter, right? So it will start from 3110, right? Make sure the address is correct. Yes. 3110, yes. Okay, correct. And I will use only 2 length, yes, because we use only a power meter, yeah. And I will start from option AI 11, yeah, because 1 to 10 we already use, and we will continue from percent AI 11, and the length is 2 words, yes. Okay, so that's all. We can connect, and then we will stop CPU, yeah, because we need to download hardware configuration. In this step, if everyone make sure that we know all the address, and we must think before we put, and we can download only one time, and we can push the project. It means that we can earn the project. Okay. If we remark the address, it means that we calculate the address before we write the program. So we can stop only one time to download, and we can cover all project, right? All data. Okay. So it's just example, so I can stop. But in the actual process, we cannot stop the CPU any many times, because process is running. So we must be careful on this point also, yes. So right now I just demo, or I just example, so I can stop the CPU because my process is not running. Okay, so I can stop and then download, yes. In this step, if we not stop the CPU, we cannot download, because we change the hardware configuration. Yes. So I download the hardware configuration to the PLC. Yes. And then I will run the CPU again. Yes. And let's check %AI 11, right? So %AI 11. Let's check to make sure %AI 11 have data or not. Yes. So right now it has data. Yes. Let's see. It show like this. It means that we put the correct address. Yeah. I mean that this address. Yeah. We put correct. So if I put any address, it means that not here. We cannot see the data. Yes. So make sure the address is correct. Yes. Okay. And if we have another power meter, we need to have this data also. Otherwise, we cannot do, or we cannot read the data, because we don't know the address, which one is volt, which one is frequency. Okay. So we must have this address. Okay. So I will convert this one to the real value also. Yes, because right now it show like this, but we don't want like this. We must show, yeah, the same as the volt. Yes. So to create the logic, we can also copy, yes, this one. Okay. This one should be read frequency from power meter, right? Okay. So I will create one more words. Yes, data variables. Yes. Okay. So go to variables and then right click and create the new variable, and I will choose word. Example frequency. Yeah, frequency show. Yeah, example frequency show. So this one, it will start from AI 11, right? This one. Yes, AI 11. So here we can write from %AI 11. And this one, I will use this variables, right? So I can write frequency show and word number 1. Yes. Frequency show, yes. Property, sorry, this one should be 2 words. Yeah. Okay. We will put this one to 2 words. Yeah. Okay. Yes, 2 words. And I can put this one, yes, to variable, yeah, frequency show, yes. So frequency show and word number 1, yes, like this, and it will earn from %AI 12, right? So %AI 12. Okay. And this one should be word 0, right? So I will change this one to 0. Okay. And this one, I will use the variable, yeah, frequency show. And this one should be frequency, right? Frequency line, yes. Okay. So we will download, yes. So validate to check it has error or not, yes. Okay, no error. It means that we can download. Yes. So connect and then download. In this step, we no need to stop the CPU because we download only logic, so no need to stop. Yeah. So download only logic. Yes. Okay. So that's good. Right now it show 50, yeah, around 50 something hertz, yeah, and I will show on the power meter also. Yes, it the same or not. I think it is the same because we already read the data. Yes. So right now it show around 49.69 hertz. Yes. So it correct to be PLC. Yes. Let's see. It's the same. Yes. So this is just instruction how to read the data from power meter to show on Proficy Machine Edition. And in the next video, I will show how to link this one to show on the HMI by using Proficy Cimplicity HMI. Yes. And I will show how to create the blocks, yeah, to be like this. Yeah. We can use the block, create only one block because it is the same format, right? So no need to create like this. We can use the block, just drag and drop the block, and then we can link to the HMI. Okay. So in this video, I would like to show like this, and I hope it clearly and it useful for everyone that want to read the data from power meter. Yes. If we have another brand of power meter, we must have the data. Okay, please remember. If we know this data, we cannot read because we don't know the address. Okay. And also manual operation, how to change the address of power meter, how to change the baud rate, or how to change the some event. Yes. So or connect the wiring connection. Yes. So we must have this. Okay. So thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon. And I would like to say sorry if I have a mistake in the video, and I would like to request all of you to like, share and subscribe my channel also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue part 3 about how to read data from power meter Schneider model PM5350. Okay, and in this section I will use Proficy Machine Edition and Proficy Cimplicity HMI SCADA to link the data to show on SCADA. Okay, so let's go to our software to create a new project of Cimplicity Workbench to show the data like voltage or frequency on SCADA. Okay, so let's go. So first I will open Proficy Machine Edition and then provide the some address to link to the HMI SCADA. Yes, so let's open the project. And I will use the existing project that we already learned in the previous video. So let's open. Okay, so here is the program, existing program that we already created in the previous video about the voltage phase A with natural, phase B with natural, phase C with natural, phase and phase voltage between line with natural and frequency of line. Yes, so I can online to show the value. Yes, okay, right now the voltage show around 229, yes, AC, and the frequency around 49 to 50 something. Yes, so we need to link all this data to the SCADA, right? Okay, so before we create the project of Proficy Cimplicity SCADA, I would like to insert the some address to link to the SCADA. Okay, so I will provide person R. Yes, this one. Okay, person R also. Yes, person R3, person R5. Yes, person R7, person R9, and the last one for frequency, person R11. Okay, so we need to download logic again because we just provide the person R to link to the HMI. Yes, so let me download the program. Yes, okay, so right now we already download complete successfully. Yes, so let's go to our software Proficy Cimplicity SCADA Workbench to create a new project to link this data to the HMI. Okay, so let's go. So to create the new project of SCADA, let's click Workbench. Yes, and then go to File, New, and choose the project. Yeah, it means that we create a new project. Yes, and we need to provide the username and password. Okay, for create this project. Okay, I will use the name example administrator. Yes, and password we can provide some password, but should we have the special symbol and the capital letter. Yes, or some number, it is required. Okay, so please provide some password. I will provide some password for my project. Okay, so right now I already put password in my project. So let's click next. Yes, and then this is a project name that we want to create. Yeah, example method. Yes, project name method, yes, and then let's click the communication protocol, yes. Right now I will use S90 triplet, yes, this driver, yes, and I will use desktop to create this project, okay, or we can create C, yes, it will go C, try C, okay, if we click like this. So let's click create after tick this protocol, yes. Okay, this is a description, yeah, that we want to mention. Example, project for read data from power meter, yes, and then click OK, yes. It will give us a project, yes. So we need to create the equipment, yes. Let's go to equipment. We have devices and parts, yeah. So first we need to create the parts, yeah. So make sure click the part and then right click and then choose new. It is the new part, and we will use the part that we already click in the protocol, yes. So it will start port 0, yes. So I will use port 0 and then click OK, yes. And this description example part for power method, yes. And it is the red scan red, sorry. So we can use 1 second, yes. And this one we can use default first, yeah. No need to change. Okay, so right now we already create the new part, yes. In the next step we will create the new devices, yeah. So go to devices tab and then right click and then choose new, and we will use the master part that we already created, yes, from here. So example part, sorry, device name example PLC1, yes. Then click OK, and here we can use the PAC system HMI, or we can use another model type that we want. So in this video I will use the system PAC system, yeah, HMI, and then goes to CTP IP, yes, that we will put it. It is related to the Ethernet module that we link from computer to the PLC. It means that here, yes, it means that here, it means that this IP address, yeah, or this IP address that we already configure, yes, here. Yes, it is the IP address of PLC that we link to Ethernet module, yes. Okay, so we can put 192.168.0.100, yes, and then we click OK. Okay, so in description we can also mention example power meter, yes. Okay, after that we can update the project by click here, yes, configuration update, and then click OK, yes. and then we can start the project. Yes. Yes. If we start project, it will log some data here. Let me show. Yes. Yes. Right now it starting the project. Yes. So wait a moment for starting the project. Okay. So right now our project is starting and running. Yes. So let's check here. Quick view. Right click on the devices and device name PLC1 and then click view. Yes. Quick view. It show like this. It means that we can link from software to the PLC. Yes, it means that can link from project of SCADA to PLC. Yes, via Ethernet module that has IP 192.1. Yeah, 192.168.0.100. Okay. Okay. So in the next step, we will create the points for link from the Proficy Machine Edition. Yes, it means that link from here, yes, to the HMI. Yes. So let's go to create the point. Yeah, go to points, and then we can dynamic. Yes, click dynamic. Don't forget. Otherwise, we can start again, stop and start the project again. Yes. So if we click the dynamic, we no need to start and stop the project again. So the points that we created, it will automatically update. Okay. So don't forget, click dynamic. Yes. So first we will create the point that related to volt A to N, right? A with N, face A with N. So right click and then new points. Yeah. And it is analog and I will use device. Then device name is PLC1 that we already created in this tab. Yes. So make sure click analog and then click device. And this is a point name or text name that we will provide. Yes. Example method 1 volt AN. Yes, like this. Method 1 volt between A and N. It means that phase A and natural. Yes. So click OK. And then here we can provide some description. Example method 1 voltage between phase A with natural. Yes. And here we can use the resource like this because we not yet create some resource. Yeah. So we need to use the default first. And the data type is real. Yes. Because here is real. Yeah. Let's see real. So we choose real. And element is 1. Yes. And then we can go to device tab and then choose the address. Yeah, address is person R1 for phase A with natural. So we can provide person R1. Okay, and then click OK. Yes. And for phase B and N, I just duplicate and change only person R. Yes. So right click on this point and then choose duplicate, and I just change this one from B to N, yes, and then click OK, and this is a face B, right? Face B, and then I will change to %R3, yes. So here %R3, so I will change to %R3, yes, and I will change this one a little bit because face B, okay, face A, yeah, okay, and the same method for voltage phase C and natural. We just duplicate and change this one to C, yeah. And then we can change this one to C, yeah, phase C, and then %R, yeah, let's check here, %R5 for phase C and natural, yes. So %R5, and then click OK, and one more for L and L, it means line to line, yes. So voltage line to line, yeah, L to L. So it is L, line to line, yes, line to line, and the data is the same because we duplicate, and %R, yes, line to line, %R7, yes. So I will put %R7, okay, and one more, we can duplicate for line to natural, yes, and then we can line to natural, so %R9, yes, and then click OK, yes, and the last one for frequency, yes, frequency %R11, yes. So I can duplicate because the data type is the same, right? Method 1 frequency, yes. So this one, method 1 frequency. So %R11, right? So I will put %R11, okay, and then click OK, yes. So right now we already created the points, yes, or text for show on SCADA. If we already created, we can right click and then choose the point control panel to let's see the data, yes. So right now let's see here, it show the data already, and then in the next step we will create the screen, right? Okay, so let's go to tab screens, yeah, and create a new screen, yes. Okay, I will adjust the geometry a little bit for high, example 250, yes, like this, and then I can go to drawing and then choose the texting for title, example power meter number 1. I will change to another color, yes, example this color, yellow color, yeah, and I will increase the size to 20. Yes, like this. Okay, and then I will write the text string follow the text that I already created, right? So this one we can copy by press Control and Shift the same time and drag and drop the mouse. Okay, we will got the new text, and then we can rename to be take A to N, right? Correct. A to N, yes, the first one. Okay, and then let's go first, yeah, like this, and we can copy, yes, A to N, B to N, C to N, L to L, L to N, and also frequency, yes, and then we can adjust a little bit, yes, by using the arrow key, yes. Okay, like this, and we can change the name, this one, B to N, C to N, C to N, yes, and then L to N, right? Sorry, L to L, L to N, L to N, and then the last one is frequency, right? Yes, and we can arrange to be like this, yes. Okay, and I will use white color. I will change to white color, yes, and then I will use the rectangle, yeah. Example like this, and I will use the text string, yes, and put like this, and I will use green color, yes, and then we can arrange to be a center, yes, like this, and we can test one point. Example, we can browse, click here to browse the points, yeah. This one we can rival and then star, method 1, yes, we can write method 1 and then star, so we can show the method that we already created the text, yeah. So the first one is A to N, right? And we can choose real, and then we can use the precision example 1, yes, and then we can test the screen, yes. Oh, so big, right? So we need to adjust the rectangle a little bit, right? Okay, so I will adjust the rectangle a little bit to be like this, and then we can arrange again, go to arrange, and then choose this one and this one, yes, So let's test again. Yeah. Okay, good. And then we will put the unit, right? It is the volt. So I can write V, it means that volt unit. And maybe I use reduce the font a little bit to 14. Yes. And then we can copy by select this one and then drag, press control and shift on keyboard and then drag and drop the mouse. Yes, drag and drop the mouse, drag and drop the mouse, drag and drop the mouse, drag and drop the mouse. So we can got like this. And this one for hertz, right? So like this, frequency, right? And here we can choose the name. Yeah, rename. So this one for BN, this one for CN, right? This one for LL, this one for LN, and the last one for frequency, right? So meter one, we need to like this, browse again. Yeah, this one, yeah, double click and click OK. Okay, so we can arrange to be good looking, yeah, like this. Yes, like this. And we can adjust to be like this. Okay, so test the screen again. Yes, we will got like this. Yes, so meter 1 volt AN BN CN LL. I'm not connect the cable, so it will show 0. And this one is the volt LN. Yes, it show around 227 something. Yes, and here is the frequency. So I will show the actual volt and frequency on the power meter. Yes, so wait a moment for I will show, yes, the actual. So right now let's see volt AN, BN and CN is around 228 something. And for frequency, let me show frequency here, around 50 something. It show the same as in our screen. Yes, yes. Go to volt. Yeah. Yes. Okay. Around 228 something. Yeah. For volt. Okay. So we can save our screen. Yeah, I will adjust a little bit for good looking. Yes, adjust a little bit. Yes, okay, like this, and then we can save the screen. Yeah, and then go to Drive C and then the project name. Yes, method, and then go to screens. Yeah, and it is the method one. Yes, and then we can tag the screen, yeah, to show like this. Okay, So this is the instruction about how to link the data of power meter to show on the SCADA, yeah, by using the Proficy Machine Edition for PLC, and then use the software of SCADA, Proficy Workbench, or we can call Proficy Cimplicity Workbench. Yes. So I hope this video is just example or instruction for everyone. And if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. And I'm also sorry if I have some mistake in this video also. And in this time, I would like to say thank you very much again, and see you next videos. Bye bye.